Hello everyone and welcome to the course. My name is Siddharth Ajmera and I'm going to be the instructor for this course. I'm a full stack JavaScript developer and I have worked on several projects involving content management systems, chatbots and single page applications. I'm the author of two Udemy courses with a total of around 32,000 plus students enrolled in them. I'm an active contributor to open source developer communities like Stack Overflow and GitHub, and I have professional programming expertise in Angular and Node. I'm also a Google developer expert for Angular and web technologies, and I write technical articles from time to time that you can find on Medium at this link right here. Let's quickly go through the course overview and the things that we are actually going to cover as a part of this course. So we are going to start with the introduction to a single page application and how Angular helps us build one. Then we'll have a look at TypeScript and ECMAScript 6, where I'll introduce some of its latest features that we'll be using throughout this course. We'll then start with the basic building blocks in an Angular application. So these would be things like modules, decorators, components, directives, services, pipes, routing, and forms. We'll also learn in a greater detail about these building blocks. So we'll have a look at things like component lifecycle hooks, Angular's change detection mechanism, dependency injection, and making AJAX calls to REST APIs using Angular. Then we'll have a look at things like implementing routing, child routing, protecting our routes, and prefetching data before navigating to a route. Using third-party libraries like Firebase and Angular Material is also something that we'll have a look at in the later sections of this course. So by the end of this course, I'm pretty sure that you'll be competent enough to build a production-ready single-page application in Angular. Now there's a lot to cover and I'm really excited to have you on board on this journey with me. So I hope to see you on the other side where we'll start with understanding of a single-page application. Okay, so this course is about building single page applications, but before we start to do that, let's first actually understand the behavior exhibited by a single page application. And in order to understand that, we are going to contrast this behavior with the behavior of a normal website. So in case of a normal website, there is a client, which is our browser, and then there is server. Now, whenever the user goes to the browser and types in, let's say, example.com in the address bar and presses enter, a new page request goes on to the server. The server interprets this request and sends back the markup for the home page of example.com in the response. The client then interprets this response, sees that it's a new page that the client has to render, so it renders that onto the UI. Now in this home page, if there is a link to say page A and the user clicks on this link, a new page request goes on to the server, and again similarly the server responds back with the markup for page A. Now on page A, if there is a say a search bar and the user types something in there and presses the search button, a new page request goes on to the server, and the server this time again responds back with the search results page or the markup for the search results page. And the client gets reloaded again and renders the search results page onto the screen. So are you noticing a pattern here? Well, the pattern here is that every time the user performs some action, in most of the cases, a new page request goes on and the server responds back with a new page, which essentially reloads the client or the browser. So the client is also getting reloaded again and again, and this is not really a very good user experience. Also, apart from this, since there are page requests are quite expensive in nature as far as the bandwidth is concerned. So a lot of network bandwidth usage would be there in case of a normal website. Let's contrast this. By the way, one of the examples of a normal website is MVMT watches. So we are going to have a look at that once we see the behavior of a single page application as well. So in case of a single page application, let's say we have a client and then we have a server. Now, whenever the user does the same thing, requests for example.com, this time the server, instead of responding back with just the home page of example.com, it's going to respond back with a complete application package. This complete application package has all the necessary JavaScript, all the necessary CSS and the fonts and all the resources that the client needs to initially load the example.com application. Now, whenever this application has, let's say, a link and the user clicks on that link, this time instead of a new page request being sent out to the server, the client itself would be smart enough to understand that, okay, there is a new route that the user is trying to access. So the application is going to load a component corresponding to that route. Now, in doing so, if this component needs some data that it needs to load, then a new data request would go on to the server, and the server is going to respond back with some sort of data, mainly in the form of JSON. Now, JSON data requests are much cheaper as compared to page requests that were sent out in case of a normal website. So, in this case, just a single request goes on to the server to load the whole application, and then multiple data requests can go. And since the server is not responding back with a new page, the client is also not getting reloaded again and again. Now, this makes the bandwidth usage very, very less as compared to that in case of a normal website. And an example of that would be the Angular IO website itself. So let's quickly have a look at the actual behavior that these two types of websites exhibit. So first we'll talk about MVMT website, wherein this is a normal website. So I'll clear the network and let's reload the application. So since this is the domain and it's going to load the homepage of example.com, let's quickly have a look at XHR, JavaScript, CSS, and font files. So in case of XHR, we can see a few calls that are being made. In case of JavaScript, we see calls to rapid.min.js and jQuery and some other script files as well. In case of CSS, we see some calls being made to Font Awesome and Bootstrap. And in case of fonts, we are seeing some fonts being loaded here again. Let me just clear it now and let me click on the Shop Now button. You'll see that this reload button switches to the cross button, which essentially means to stop loading the page. But now, as you can see, the same fonts that were loaded previously are being requested for again from the server. Same would be the case with JavaScript, wherein you will see that we have already loaded the rapid.min.js as well as jQuery, but still a new call is being made and these resources are again requested, even though they were already loaded in the previous request. Right? Now let's quickly search for something here. So let's say if I click on the search bar and let me type something like Sam Colder here. Now, when I pressed enter, a new page request went on, as you can see here, and this is the search results page. But then on this search results page as well, you'll see the rapid min.js and jQuery being loaded again, even though they were already loaded. Same would be the case with fonts. The fonts were also loaded again. And same would be the case with CSS, wherein we can see that there's a call being made for Font Awesome as well as for Bootstrap. So as you can see here, again and again multiple page requests are going on. Another thing that you might have noticed is that to load the whole page, it's taking quite a lot of time in this case, and the application is getting reloaded again and again. This gives more of a janky user experience, and the bandwidth is also being leveraged or utilized quite often. As you can see, there is a lot of megabytes being downloaded here, which doesn't really makes for a very good user experience. Let's now compare this with Angular, which is a single page application. So let's say I go to the Angular IO website and let me just reload this. So in this case, a document request went on, but along with this document, the complete application package got downloaded. So if we have a look at JavaScript, we see runtime, polyfills, main, and some other scripts being downloaded. In case of CSS, we see some CSS files being downloaded, and same is the case with fonts. But this time, if I, let's say, click on this API link here, it takes me to angular.io/API, as you can see in the bottom left hand section of the screen. So if I click on this, you'll see that the application didn't really reload. Rather, some other request was made. Let me just clear this and do that thing again so that you can see it properly. But another thing that you notice here is as soon as I went back to the home page, a new page request was not really made. Only the XHR as well as the images that were really required to load this page were made. And same is the case with JavaScript. No new JavaScript was loaded because all the JavaScript was already in the application bundle. Same is the case with CSS and same is the case with font. Now, if I open the API page, you'll see that no new fonts were downloaded, no new CSS, no new JavaScript because we were already on this page. So that's not really the case, but some images were required, so these were downloaded. Now let's say if I search something here, let me just clear this. If I search something here, let's say view child, and click on this, um, these were a few scripts that were really required. But apart from that, and there was also a font request that was made, but this font was really not available as a part of the previous font requests that were made. But apart from that, all the CSS was already there on the client, so it wasn't really requested for again. So this basically is the major difference. You'll also see that this application is not being loaded again and again if I click on the links right here. So the application is loaded very fast, and this gives this application more of a desktop application like feeling, and the user experience is also very smooth in this case. So this is the basic difference between a normal website and a single page application. Let's in the next video see how we can actually use Angular to build a single page application. So I'll see you guys in the next one. Alright, now this course is all about Angular, and this is something that we are actually going to use to build single page applications. But before we start to do that, let's first try and understand why exactly are we using Angular in the first place and not any other front-end framework. So what do we need Angular for? Well, Angular is a front-end framework. It's an end-to-end framework, and these days it has become more of an ecosystem. With the help of Angular, you get things like Protractor that you can use for end-to-end testing of your Angular application. You get forms, so you can build highly performant forms, both template-driven and reactive, as well as dynamic forms. Then Angular comes with the progressive web app schematic that you can use to incrementally introduce progressive web application features into your existing Angular app. It comes with Augury, which is something you can install as an extension for your browsers like Chrome and Firefox, and this helps you make more sense while debugging your Angular applications. Then it comes with language services that provides code completion, errors, hints, etc. in your Angular templates. Also, it's built using TypeScript, so you can enjoy incredible tooling support for almost all the IDEs that enable you to focus on build amazing apps rather than trying to make your code work. Then it comes with router that actually makes Angular applications single page applications. Then it comes with elements that you can use to package an Angular component as a custom web component, and then you can use it with any other front-end framework or just by using HTML. It also comes with Component Development Kit, which is a set of tools that you can use to implement common interaction patterns. You can also render your application server side by using Angular Universal, and this gives you features or capabilities to increase or improve the search engine optimization in your Angular apps. Then it comes with Karma, which is the test runner. It helps you in running your unit tests. Angular team is also working on the Labs project, which is basically an initiative by them. The Labs team works on bringing new features like schematics and IV to Angular. Angular also comes up with its compiler, which is smart enough to do things like automation and bundling of your Angular applications. Then it comes with internationalization support as well, so you can build your application and then deploy it for any specific geography that you want. It also comes with HTTP capabilities, so you can make AJAX calls, fetch resources, implement things like authorization, etc. in your Angular apps. Material design, which is a design language for Google, is also quite popular these days. And with the help of Angular Material, you can introduce that into your Angular apps. You can also introduce animations into your Angular apps using the Angular's animations modules. Finally, Angular comes with Angular CLI, which is one of the most powerful command line interfaces out there. With the help of Angular CLI, you can scaffold out an Angular application in seconds. So, that's not just all. Along with that, there are also aspects related to where exactly or how exactly can you ship apps using Angular. So Angular already helps you build web applications and mobile web applications, but again it comes with the progressive web app schematic that you can use to incrementally introduce the features of progressive web apps into your already existing Angular application. Now, if you are looking for more of a hybrid mobile application solution wherein you want some sort of a reusable code that you can then build and publish as an Android app or an iOS application, then you can use Ionic along with Angular to build that. If you are looking for a native solution instead, you can use native script with Angular to build native applications for Android and iOS. Finally, with the help of Electron.js, you can also use Angular with that to build desktop applications. And that's not all. There are also some other things. So Angular comes with dependency injection. It follows a component based architecture and allows you to create reusable plug and play components. And it uses hierarchical dependency injection, which eventually boosts performance. Angular also comes with features of lazy loading using the Angular router module. So you can basically divide very big application into smaller modules and then you can lazily load those modules on demand. With the help of Angular, you can also build component libraries and then you can reuse them across your enterprise. Now, building super speedy and highly performant and scalable applications is easy with Angular because Angular is built for performance. And it also has support for templates. So you just have to write templates in normal HTML that you are used to using instead of JSX or TSX. Plus, Angular makes the development process less painful and the code more manageable and unit testable. And it has support by Google and it's not going anywhere anytime soon. And the developer community is booming. It's also easier to learn Angular as compared to its previous AngularJS, and it gives you a flexibility to be written in JavaScript, that is ES5 and ES6. You can also write it in TypeScript and Dart. And it has a fast change detection mechanism that can be fine tuned to make your application 3 to 10 times faster. With all of that being said, it should be quite safe to say that Angular makes our lives easy. So we are going to set up a development environment in the next video so that we can write our first Angular application. So I'll see you guys in the next one. Alright, now in order to run Angular on our machine, we'll need to set up a few things and install them. The first thing that we'll need is a browser. Assuming that you're watching this video on a browser, I'm pretty sure that you will be having one installed. But I'll still suggest you to install the latest version of one of these browsers. I'll be using Google Chrome. You can simply click on this link here to open up the download page for that specific browser, which is something that I've already done here. The next thing that you'll need is Node.js. Node.js comes with Node Package Manager that we will be using to install dependencies like Angular CLI and the dependencies that our Angular apps depend on. So to install Node.js, you can click on one of these links. Both of them takes you to the download page. So the one for the latest version is this. I'm using Windows right now, but you can install one that is suitable for your machine. I already have Node.js installed on my machine. Once you click on this and install it, you can verify whether it was installed properly or not using the terminal. Since I'm a Windows user, I'll be using the command prompt. So to check and verify whether Node.js was installed, you can type in node space -v. V here stands for version. So this tells me that I have the version 12.11.1 installed on my machine. Node also comes with Node package manager, that is npm. So to check the version of npm, I will do npm space -v, and this gives me the version of npm installed on my machine. Now, the third thing that we will need is TypeScript. So we'll need TypeScript to install the TypeScript compiler, which will transpile the TypeScript that we write into JavaScript. So to install TypeScript, you can just click on this link and it takes you to the downloads page wherein you can run this command. So if you just copy this and go back to your terminal and just paste it there, and if you press enter, then it's going to install TypeScript in the global mode. Now I already have TypeScript installed, so I can just check whether it was installed properly or not. To do that, I'm going to run tsc, that stands for the TypeScript compiler, space -v, and that should give me the version of the TypeScript compiler installed on my machine, that's 2.9.2. Next up, we will need Angular CLI, that's the command line interface that comes as a part of the Angular ecosystem that we talked about in one of the previous videos. So to install Angular CLI, just click on this link right here and it takes you to the npm.js page for Angular CLI. You need to run this command in your terminal in order to install Angular CLI. So you do something like this and then press enter, and it takes some time to install Angular CLI because it comes with quite a lot of packages. So once Angular CLI is installed, a command named ng is available for you to use. If you want to check whether Angular CLI was installed properly or not, you can just type in ng space -- version and then run it. So it tells you that Angular CLI's version 8.3.8 was installed properly. I guess this is the latest version at the time of recording this video. So this might change from time to time based on the time that you are watching this, but then the process to install it is just that you copy this command and then you run it onto your terminal, and that installs Angular CLI. The final thing that we will need is a code editor. So these are a few code editors that you can use. I recommend using Visual Studio Code, and that is also something that I will be using. So just click on this link here and it takes you to the download page. Here you can install the version that is suitable for your machine. Now installing all these things and the steps that you actually need to follow is something that I've wrote down in an article. Here's a link to that article. You can just click on this and it takes you to this article on Medium that I've written. It tells you and guides you through a step-by-step process of getting started with Angular. So just have a look at it, and then if you have any issues, then you can feel free to comment on this article and I'll be happy to help you. There are a few optional things that you might want to check out and install. The first one is Augury, that is a browser extension available for both Chrome and Firefox. This extension can be used to debug Angular applications in a better way. I've already installed it for Chrome, so I won't be doing that as of now. But if you want, you can download that particular extension by clicking on one of the links suitable for your browser. The next thing is font ligatures. So font ligatures makes your font look something like this. So let's say if you are using a triple equal to sign, then it transforms that and renders it like this. So it looks a bit good as compared to the same monotonous fonts that we actually use. Again, it's just up to you whether you want to actually use it or not. One of the things that I highly recommend you to use though is the VS Code's auto import plugin. So you click on this link and it takes you to the auto import plugin page here. You can click on install and it guides you to open up VS Code and then install it in there. This is something that we'll be using quite a lot while working with our project, so I highly recommend you to install it. Again, all these steps are written in the article that I told you about previously on Medium. So just check it out, and if you have any doubts, then you can comment on it and I'll be happy to help you. Now, if you don't really want to install all these things, set up the development environment in order to run Angular applications and build them, you can use one of the online tools. So there are three tools that you can check out. One of them is StackBlitz. So you just click on this link and it opens up StackBlitz, and it gives you a fresh Angular project to start with. This is how the interface looks like, and this is actually something similar to what we will experience in Visual Studio Code. So it also has an Angular generator. So once you right click and hover over Angular generator, it gives you a few building blocks that you can create using the Angular generator. Let's say if I wanted to create a component and call it, let's say, Ola, it created an Ola component for me right here. Apart from that, similarly, you can also create some other Angular building blocks like a module, a guard, a service, a directive, etc. So you can use either this. You can also use Code Sandbox, which is a similar kind of website that also lets you build Angular applications. This doesn't really have the Angular generator though, so you'll have to create everything manually. So if you don't really want to create everything manually, then you can use StackBlitz. Finally, you can also use ng-run. This is another similar website. The only drawback of this is it's just for Angular applications, while on StackBlitz as well as on Code Sandbox, you can also create other types of applications like a React application or a TypeScript application and so on and so forth. But another thing is it's very minimal in nature, and you can use it to actually create or generate Angular components, directives, services, etc. So I'll still recommend you to use StackBlitz if you are going forward with the online approach and don't want to install all these things on your local machine. Next up, we are going to talk about the Angular application architecture. So I'll see you in the next video. Now, before we start to build Angular applications, we need to have a good mental model of how an Angular application is structured. So this is exactly what we are going to talk about in this video. You might have heard of this before, but an Angular application can be considered as a tree of components. Now, since this is a tree, the tree needs to have a root. So this root is going to be the root component, or it is by convention the app component. The app component is then going to instantiate the whole application tree incrementally one by one. So let's say that there are 4 sections in our application. Let's say we have an e-commerce website. So in that, there can be things like the login page, sign up page, and the forgot password page. There can be things like the product details page and the products list page. There can be a cart page wherein we can see what all things we have added to the cart. And then there can be a checkout section wherein the user can fill in their address details, their payment details, and then see the confirmation for the things that they've ordered via the cart. So keeping that in mind, our Angular application can further render 4 components: the auth component, the browse component, the cart component, and the checkout component. Now, since the auth component can have 3 different views like login, sign up, and forgot password, it can further instantiate 3 more components. That's these 3. The browse component can instantiate the product list component and the product details component. The cart can instantiate a list of components, and each item in that list can then further be created as its own item component. And the checkout component can further instantiate 3 different components like the address component, the payment component, and the confirmation page component. Now, each of these parent components, that's the auth, browse, cart, and the checkout component, are further instantiating child components. So these groups of components can be considered as sections of the application that are dedicated to a specific domain or workflow. So they can be abstracted into a module in itself. So the auth component and all its child components can be abstracted into an auth module. We'll do the same with the browse component, the cart component, and the checkout component, thereby creating a product module, a cart module, and a checkout module. So This gives us an overall application architecture wherein our Angular application will have four modules. That's the auth module, the product module, the cart module, and the checkout module. And then each module in itself can contain multiple things. So let's say if we talk about the cart module, then it can have a few components. There can be services. This module can have some directives as well. It can have routing and some other sorts of configurations and other building blocks in place. So now that we have a good mental model of how an Angular application is structured, let's go ahead and build our first Angular application in the next video. After watching the past 4 to 5 videos, I hope that now you have a pretty good background of Angular. So it's finally time for us to build our first Angular application, and we are going to use Angular CLI for that. So these are a few commands that we are going to run in order to actually install Angular CLI, check whether it was properly installed or not, and then build a new application using Angular. So I'm going to use command prompt. So I press Windows plus R. This opens up this run window. I type in CMD and then I press OK. And that opens up the command window for me. Now, I like to generate all my Angular applications inside the C drive, inside a folder named development, inside a folder named Angular. So that's where I'll navigate. And after that, I'm going to generate a new Angular CLI project. I've already installed Angular CLI. So I will be running ng space new, and the name of this application, let's call this my shiny new Angular app. All right. Now this is going to take some time in order to run. So we'll just have to wait. Since we are running the latest version of Angular CLI, it asks us for a few options, like whether we actually want routing or not. So let's wait for it to actually ask all of that. Yeah, so it asked me whether I'd like to add Angular routing to the project. I'll just say yes as of now. Now it asks me what would be the style sheet format that I'd like. I can just press the up and down arrow keys to select one. And let's say I go with SCSS, so I press enter for that. And now it starts to generate all those files for me. And after it has generated them, it's going to now install all the dependencies that this project is going to need in order to compile properly and then run. So this is going to take quite some time because it's now installing all those dependencies over the network. So let's wait for it to do that. Now, once all the dependencies are successfully installed, this is the sort of screen that looks like after all the installation and all the relevant processes gets completed. So I can now navigate to the project folder. That was my shiny new, I guess. Yeah. So I'll navigate here, and then I already have Visual Studio Code installed on my machine. So I can type in code space dot. What this is going to do is it's going to open up Visual Studio Code with this folder. So we can see that it has done just that. Now there were quite a lot of files that were generated in the process, and this is something that we are actually going to have a look at later. But as of now, let's first start by running the project. So I pressed Control plus backticks, and that opens up this window. Right now it's in the PowerShell mode. Let me just close this message, and it takes some time to initialize this PowerShell. Meanwhile that happens, let's open up the package.json file. This is the file that has a few things like the scripts object, which actually tells us a few commands that we can already run in this project. So one of them is ngserve, that serves up the application, spins up a local development environment, and starts serving the application on that local environment for us. So that is one. Then we have other commands like ngbuild, ngtest, ngbuild for building up the Angular application, ngtest for running unit tests on this application, nglint for linting the application and checking for all the linting rules. Then we have E2E that runs the end-to-end test cases. Okay, so now that the PowerShell window is initialized, let me just convert it into command mode by typing in cmd, and I'll press enter, and this converted to cmd. Now I'll just type in cls to get rid of all the text, and now I'll run ng space serve and press enter. Now what this is going to do is it's going to initially build up the whole application, and then it's going to serve up the application on localhost colon 4200. That's the default port number on which the application gets served. Let's quickly have a look at the slide now. So we have already generated an Angular application, and we have already run ng space serve to serve up that application, and it's being built right now. It's eventually going to get served. That might take some time for the initial building, but then it will be a fast process. Then these are a few commands that we have already seen in the package.json file. There are a few other commands that you can run with Angular CLI, and there are links to all those commands right here. So you can just click on these links and it will take you to the relevant page with all the relevant information for these commands. One of the important thing is that you might want to run multiple applications together. So you can also specify a host and a port by using the hyphen hyphen host flag for the host and the hyphen hyphen port flag for the port. By default, the Angular application serves up on localhost 4200 port number. So let's quickly see what's going on. Okay, so it's running the build. Let's increase the size of this window, and it has built the application till 30% as of now. It's going to quickly do that. Meanwhile, let's have a look at some other commands that we can run. So these are a few building blocks of an Angular application that we are actually going to have a look at in the third section of this course. But essentially, you can see similar commands for any specific building block. It starts with ng, that's the Angular CLI. G stands for generate here. C stands for component. So you'll see ng space G being common, while the actual building block that you have to generate is being short formed here. So in case of component, that would be C. In case of a directive, that would be D. In case of pipe, that would be P. Services S, and so on and so forth. You get the general idea, right? Now after that, we specify the name of this building block that we have to create. So in case of a component, we'll just type in component hyphen name or any specific component name that you want to actually give for this component. Same would be the case with all the other building blocks. Now one last thing to note here is that the Angular CLI is going to generate a folder for just the component and the module. Apart from that, all the other building blocks like directives, pipes, services, class, guards, interfaces, and enums are not going to have their own folder. So you'll have to generate or type the command in such a way that it actually generates that folder for you. And this is actually something that we are going to have a look at when we generate these things using the Angular CLI. So let's see. As soon as the compilation gets successful and the server is spin up, it will show a message that looks something like this. So now I can simply go to localhost colon 4200 and run the applications. So I'll open up a new tab. I'll type in localhost colon 4200 and press enter. And this is the title of my application, which says my shiny new Angular app. And this is what the home page of this application looks like. Now it has a few things here like resources. So if I click on the links, you can see in the bottom left hand section of the screen that it takes me to the following links. Like this takes me to angular.io/tutorial, this to the Angular CLI documentation, this to Angular blog that's present on Medium, and then there are a few next steps that we can do. So to generate a component, this is the command that we can run. For introducing Angular material, we can run this command, which will basically add Angular material to our existing project. For adding a dependency, we can add a dependency like this. So here on the blank section, we have to actually specify the name of the dependency, just like we did for Angular material here. We can also run our tests using this command, and we can build for production using ng build space -- prod. Apart from that, there are a few other websites and a few other parts to this whole ecosystem of Angular. So you can have a look at these as well. So this is our first Angular application that we successfully created and ran. All right. So now that we are done with this, in the next section, we are going to talk about TypeScript and ECMAScript. So I'll see you guys in the next one. Hello everyone and welcome to the section 2 of this course. I'm really excited for you guys to be in here, and in this section we are going to talk about TypeScript and ES next. Now TypeScript and ECMAScript standards are things that are evolving quite rapidly with time. So by the time you actually end up watching these videos, the version of ECMAScript might not be ES6 or ES7, right? So that's why I've written ES next here, and I'll make sure that as soon as a new feature is introduced in any of these and it's something that's quite useful during our development process, I add a video about it in this section. So we'll make sure of that. All right, now what exactly is TypeScript? So you can think of TypeScript as a superset of JavaScript. What that would mean is any valid JavaScript is essentially a valid TypeScript. And TypeScript offers you things like optional static typing, which can prevent runtime errors. So this would make more sense if you come from a statically typed language background like Java or C Sharp, wherein you can get compile time error checking. So this is something that is quite useful, and with the help of TypeScript, you can bring those features to JavaScript as well. Now TypeScript cannot really be embedded directly into a web page. So browsers are not really capable enough of running TypeScript out of the box. Hence, you need to transpile the TypeScript to get JavaScript. This is the exact same reason why we actually installed the TypeScript and the TypeScript compiler in the previous section. TypeScript also allows us to leverage modern features of ECMAScript standards like modules, constants, interfaces, classes, arrow functions, etc. And it's also open source, so you can actually have a look at the source code of this. Even though this is supported by Microsoft, it's open source, so you can also contribute to it and you can suggest features for the next versions. TypeScript offers excellent support for IDEs, so things like IntelliSense, error reporting, inline code help is something that you get when you run TypeScript in most of the modern IDEs like Visual Studio Code, etc. Then the TypeScript compiler also helps us guarantee that browser compatibility is retained. So we can transpile TypeScript to JavaScript that can run both on the older browsers as well as on modern browsers. So that is something that the TypeScript compiler takes care of. Now, these are a few features that we are going to actually talk about in this section. So we'll first start with variable declarations like let and const, and then we'll talk about static types. So things like primitive types like string, boolean, etc. And then we'll also talk about some of the user defined and complex data types. Then we'll have a look at three operators, that would be the spread, destructure, and rest operators. Now in Angular, almost everything is essentially a TypeScript class. but it is decorated with something. So for that, we'll need to understand classes, and we also use interfaces and generics quite a lot in Angular. So that is also something that we'll have a look at in this section. Finally, we'll have a look at things like arrow functions, modules, and namespaces. And there were new APIs like fetch and async await that were recently introduced. So that is also something that we'll have a look at. Now these are not all. As soon as a new feature is introduced, I'm gonna make a video about it and I'll add it to this section of the course. Alright, now without further ado, let's get started, and in the next video we are going to talk about variable declarations. That would be the let and const keywords. So I'll see you guys in the next one. From the next video onwards, we are actually going to write some TypeScript code. To do that, we'll need some setup in place. You can either use StackBlitz for it, or you can do it on your local as well. I'll first start with the local setup. Let me just open the command prompt by pressing Windows plus R key and then typing in CMD and then OK. Here, let me navigate to the C drive development folder, inside which there is a folder named TypeScript that I've already created. Now in here, I'll create a folder. I'll call it course, and I'll navigate to the course folder, and then I'll open VS Code right here. Alright, so the VS Code is open now. I'll make this an npm project by initializing an npm package here, and to do that I'll open up the terminal. So control plus backticks. Right now I'm in the PowerShell mode. Let me just switch to command mode by typing in CMD and pressing enter. And now let me just initialize an npm project. So npm init does that. I'll press enter, and then it will ask me for a few questions. These are the questions that it asks me to actually configure my npm project, and with the answers that I provide to it in these questions, it's going to generate a package.json file for me, which is some sort of a configuration file for npm projects. I'll just let the values of all these questions be the default ones by simply pressing in enter on each and every question. Let me just type in my name as the author. And yes, so as soon as I do that, you'll observe that a package.json file got created here. And this package.json file has all the exact same values that I specified as the answers in these above questions. So if I open that up, you'll see the exact same things. The author is my name, rest all is default. It also has a scripts object, and this scripts object is something that is quite useful. You can basically specify some commands here that you want to run quite frequently, and then name those commands something. Let me just clear the terminal by typing in CLS. Alright, now if I create a TypeScript file here and call it, let's say, index.ts, and type some JavaScript in here. Now, as I already said, every valid JavaScript is essentially valid TypeScript. So if I type in hello world in here and save, and if I run this through the TypeScript compiler, it's going to generate a JavaScript file for me, because that's what the TypeScript compiler does. To do that, I'll run a command tsc, that stands for the TypeScript compiler. It accepts the file that we want it to compile, that would be index.ts, and then there is a mode that is the watch mode that the TypeScript compiler can run in, but that is something that it does with a flag when we specify it. So a -w flag makes the TypeScript compiler run in the watch mode. So if I run this now, it says that it started compiling in watch mode and it found 0 errors, and it's now watching for file changes. Let's first quickly see the file that it generated. So this should just have console log here, because that's what we typed in here. No specific TypeScript as such. Now if I change the TypeScript file to hello there and save it, then it will detect that change in the file and then it will run the TypeScript compiler again, and this time it updated the index.js file. Now I have to run this JavaScript file in the browser to actually see whether the generated code works or not. So I'll create an index.html file here, and in here let me just type in some HTML5. This was generated by Emmet, by the way. That's why I was actually suggesting you to use Visual Studio Code, because it comes with all these things like Emmet. And at the end, in one of the scripts tag, I'll include index.js file. I'll save this and let me just open this in Explorer and open the index.html file. Now there's nothing that we have added as such to the body, so you won't really see anything here. But if I open up the developer tools by pressing right click and then using inspect and then navigating to console, I'll see a hello there being printed. So this is how we will be actually using the Visual Studio Code setup to run TypeScript as of now. Also, I did say that we have this package.json and there is a scripts object in here. There is a script that you can run and the name of the script is start, and the value of this would be one of the commands that we are going to run frequently here, and that command would be this. So I can simply use this command here and not type that again and again, because it has some things like the W flag which I don't really want to miss whenever I'm running it. So I can just create a script out of it, and now I just simply have to run this script instead. You can just type in npm start and press enter, and that is going to run the TypeScript compiler for us in watch mode. So if now I just use hello instead of anything else, it's going to actually watch these changes and update the generated JavaScript file. And there is another way of running this. So if you don't really want to do all of this setup, then you can simply navigate to stackblitz, and you can fork TypeScript from there. So stackblitz.com/fork/TypeScript. So if I enter, it's going to fork TypeScript and show me this project right here. Now, I don't really want to append anything to the body, so I can get rid of this. But then as soon as I type something in here and then essentially log it to the console, I'm still going to be able to see that on the console. So hello world. And it's going to happen in watch mode as well. So if I open up the console, I'll see hello world being printed here. If I change that to hello there and save, I'm going to see hello there printed. So this is also something that you can use. All right, I guess now we have the setup in place. So from the next video onwards, we can actually start to have a look at variable declarations. So I'll see you guys in the next one. Okay, so after setting up the development environment for typing in TypeScript, it's finally time for us to learn about the new variable declaration syntax, that is let and const. But in order to actually appreciate why let and const were introduced, we need to understand the issues with the previous variable declaration mechanism, that was var. To do that, let's dive into code. And here I'm going to create a file and I'll call it var.ts, and let's add the generated JavaScript to the scripts tag in the HTML file. Now, a variable declared with the var keyword is hoisted, and the scope of a variable declared with var is that of a function. So let's say that I have a variable here, let's call it pat, and let me assign this variable an emoji of dog, and let's make a function, call it set pet, And inside this function, I'm going to create another variable and call it pet. And inside, I'm gonna set that to a cat. Now let's log the variable pet to console. I'm using the backticks syntax here, and this is how you use the value of a variable that we have defined. So you use a dollar and some curly braces, and inside that you specify the name of the property that you want to log. So this only works with backticks. It won't work with a single quote like this. It won't really print the value of the pet variable here. So it only works with backticks. All right. Now let me do one thing by calling the set pet method here, and then after that let me log the pet variable to console by doing this again. So pet outside the house. Let's save this, and I've already added the script for this variable.js file that is going to be generated by our TypeScript compiler. I'll just change this to var.ts as of now, and let's run npm start. Now this takes some time to actually build the TypeScript file, and once it does that, it's going to generate a JavaScript file, and we have already added it to the index.html here. So I can now go to the browser. So it says that the pet in the house is cat, but the pet outside the house is dog. Now let's see what's happening here. So ideally, I called the set pet method, right? And I assigned pet to a cat. So before logging the variable pet to the console, I called the set pet method. What this should have done is it should have set this pet to the cat variable or the cat emoji, but that didn't really happen, right? So the issue with var is, if var is declared in a particular file, then it takes the scoping of the main function. So what that would mean is, since var is outside the setPad method, it's basically on the main function that sits on the window object. So if I just type pet here, I'm going to see that here. Yes, and that is also the case with the setPad method. So if I call setPad, then it's going to log whatever the setPad method has. So what's happening here is, since I called setPad and declared the variable with a var keyword, the pet variable that we have here inside the setPad method is only scoped inside this function, and that's why outside, if I log pet, it's still referring to this pet variable. So its scoping is just limited to the function. Now let's check another example here. So let's say if I use a for loop and I have an index property that I set to 0. If I use the exact same property var index equal to 0, index less than 5, and index plus plus, and inside let's just log in index in here first, and outside the for loop is this index. Now what exactly is going to be the value of index that gets printed here and the one that gets printed here? So ideally, since var is also subject to hoisting in JavaScript, what will happen is, even though we have declared a variable here that's going to actually get hoisted, and it's going to get declared here again. So something like this. And then once we get to this point, then it's going to get assigned the value of 0, and in increments it's going to get its value changed. So finally index is going to be set to 5. So the the index outside the loop is going to be 5 finally, although we set it to 0. So if we run the code, then outside the value of this is going to be 5. So this also points to one of the problems with var, and that's it getting reassigned and it having issues like hoisting. Now what let does is it overcomes these problems, and it does not allow redeclaration and shadowing of variables declared with let. That was actually the case with variables declared with var, and that's something that we have already seen, and it's block scoped. So it needs to be declared before we can actually use it. So let's quickly see what I mean by block scoped. Let me create another file. I'll call this let.ts, and maybe I can add another script here, and this would be let.js. I'll simply copy this code from here and paste it here. Let's just rename this to internal. So we only want this index to be available inside this for loop and not outside it. So let's define it as let instead of var this time, and instead of index I'll use index internal, and that's what I'll be logging in here. Now I won't be able to log it outside, and I'm already getting an error here, and that's because since a variable declared with the lat keyword is block scoped, so the scope of this variable is only going to be inside this for loop. So if you see, a block simply means anything that is between an opening curly brace and a closing curly brace. So that would mean that this thing right here is a block, and the scope of this index internal is only inside this block. So outside we are going to get an error if we try to access it. That wasn't really the case with a var keyword, as we have already seen here. So since I'm already getting an error, this actually works, and I had to declare it first, and then only I was able to use it. So that's one of the issues that is fixed by the let declaration mechanism. Now there is another thing that's called const, and const is almost similar to let. The only difference with const is it cannot be reassigned. So internal states of a const can be modified if that is a complex data type, but as far as it's a primitive data type like a string, a boolean, or a number, the state cannot be changed in case of const. And let's quickly see that in action as well. So I'm gonna create another file this time, and that would be const.ts, and here let me define a const. And the thing with const is you will have to assign it a value at the time of declaration. So you cannot do something like my num and then assign my num equal to 1. You cannot do that with const. You'll have to define it right when you declare it. Now that's not really the case with a variable declared with the let keyword, because in that case you can actually declare it first, like my number, and then define it. So my number equals 1, right? So now that we have already declared as well as defined a constant, we cannot really change its value. So if I try to do something like 2, then it's going to give me an error. Now it's immutable in nature and you cannot really change its value. So that actually happens with strings as well. So you cannot do that, and that also happens with a boolean. So again, the value cannot be changed once it's defined. That isn't really the case with complex data types like objects. So let's say I declare a variable called my object, and then I'll have to assign it a value. Let's say I have a variable here called foo, the value of which is bar. Now I cannot do something like my object equals another object and then bar e- equals baz. Doing this is going to give us an error because the my object does not have a property bar on it when it was initially defined. But we can still trick the TypeScript compiler into thinking that no new property was added by adding a property and assigning it a value like this. So I won't be getting any error at this. Right now, it's not really compiling the const.ts file, it's compiling the var.ts file. So let me just terminate the batch job. And in package.json this time around, instead of just compiling var.js, let's also compile let.ts and const.ts and save this. And this is going to generate a const.js file, which I'll add to the scripts as well. Let's run npm start now. And as you can see, it generated a const.js file. So if I go back to the browser now and reload the application, since in this case I have not really declared and defined these variables inside a function, they'll essentially be present on the window object. So I can simply access them by typing their name in the console, my num and my object. Now as you can clearly see, the state of my object has been mutated since I already added a new property onto it. But if I tried to do something similar to my num, I would get an error and the TypeScript compiler would complain. So let me just get rid of this and save it. And if I go back here and reload the app, I can still see the expected behavior of my num being 1 and my object having both those properties. And that brings us to the end of the video. To recap, in case of const, it has the same scoping properties as that of let, with the only exception that it cannot be reassigned, unlike let, which can be reassigned. And the internal states of consts can be modified in case they are complex data types like arrays and objects, etc. Next up, we are going to talk about primitive data types. So I'll see you. Now, there are a few primitive types that we quite frequently use throughout our applications in Angular and TypeScript. These are a few primitive data types that we generally use. We have booleans, that's true or false. Then we have numbers, and numbers can be binary, they can be decimal, they can be octal, and they can be hexadecimal as well. Then we have strings, null, and undefined. So we are going to examine all these primitive data types in this video, and to do that, let's jump right into code. So I'll create a new file and I'll call it primitives.ts, and I'll also add that to the start script primitives.ts and save that. And let's also add this to the script primitives.js. Now if I break the terminal job and run npm start again, that would also compile the primitives.ts and generate a JavaScript file for us, which it did. Since both these files are empty as of now, let's start by typing in some code now. So first we'll talk about booleans. In order to assign a particular type to a declared variable in TypeScript, you supply the name of the variable. So let's say authorized is the name of the variable, and I use a colon and after that I supply the type of this variable, so that would be boolean in this case. Now since this is declared with the lat keyword, I can use this on the second line and assign it a value. So this value can either be true, it can be false, but it cannot be a number, because then the TypeScript compiler is going to complain. It cannot also be a string. In that case as well, it's going to complain. It can be null though, and it can be undefined as well. And it can also be a function that returns a boolean. So if I call a function, so this is a self-calling function, let's say, and this returns either true or it returns false. Right here I'm using the arrow function. I'm wrapping it inside parenthesis and then I'm calling it like this. So these are all the different values that a boolean can assume. Then we have numbers. So let's say that there's a number, my number, which is of type number. Now this number can be a decimal. So it can be 10 minus 10, 10.10 minus 10.10. It can be a binary number. Then it can be a hexadecimal number. It can be octal. It can also be a function that returns either of these. So I'll have to again make this a self-calling function. It can be null and it can also be undefined. But again, if I try to assign it something other than a number like a string or a boolean for that matter, it's going to complain like this. So we cannot assign it all these values. Then we have string. So let's say that I create a username property and this is of type string. Now the username property can assume a string in double quotes, in single quotes, backticks. It can assume a value that is obtained by calling a method on the string. So if I call to uppercase on this, this also returns a string, so it's valid, as you can see here. Then I can call a self-calling method that returns this string like this. It can assume a value of null and it can assume a value of undefined as well, but it cannot assume a value of a number. In that case it's going to complain, and it can also not assume a value of type boolean like false. In that case as well, the TypeScript compiler is going to complain. Alright, next up we have null. So null can only have a value of either null or undefined. So let's say that I have some data property and the type of this data property is null. So data can now be either null or it can be undefined, or it can be a function that returns either null or undefined. So again, if I create a self-calling function and either return null and then call it, or use undefined as the return value, then that also works. But it doesn't work if I assign it a value of a string or a number or a boolean. So in all these three cases, it's going to complain. Same is the case with undefined. Let's create another variable here, and this time instead of data, let's call it user data. So if the type of user data is undefined, then it can either assume a value of null or undefined, or a method that returns null, or a self-calling method that returns an undefined. But it can again not assume a value of a string or a number or a boolean. And in this case as well, the TypeScript compiler is going to complain. So to recap, we discussed all these primitive types. Those were booleans, numbers, string, null, and undefined. In case of boolean, a variable that is declared with type boolean can assume a value of true, false. A self-calling function that returns a boolean, it can assume a value of null and undefined. In case of numbers, a variable that is declared with type number can assume a value of a positive or a negative decimal, a hexadecimal. It can be binary, it can be octal, or it can be a function that returns any of these above numbers. Also, it can assume a value of null and undefined. Then we have string that we saw, and a string can assume a value of some text in single quotes, in double quotes, or in backticks. It can also assume values that are returned by functions that are called on strings, or functions that actually return strings. And then they can also assume values like null and undefined, just like the other primitive data types. Then we have null that can assume a value of null and undefined, and same is the case with undefined that can again assume a value of undefined and null. Next up, we are going to talk about reference types. So I'll see you guys in the next video. In the last video, we talked about primitive types. In this video, we are going to talk about some reference types like arrays and objects, and some special types like void and tuple and any. So these are a few types that we are going to talk about. First of them is void. So let's see what this would mean. I'll go back to the code editor and let's first talk about void. Void is a data type that we generally assign to a function that returns nothing. So let's say that we have a function called log to console. Now this function is not going to return anything, so I can assign a void to it like this. The only job of this function is to log something to the console, let's say hello world. Here this function doesn't return anything like a number or something, and if it tries to return that, then the TypeScript compiler is going to complain because we have specified the return type as void, so it cannot return anything. And if we simply put a return here, then it should work as expected, because returning nothing would simply mean returning void, so that makes sense, right? Okay, the second thing that we are going to talk about is arrays. There are multiple ways of declaring arrays in TypeScript. So the first one would be to declare an array like this. So my array is an array of type string. Let's name this fruits. Fruits can then have only strings: an apple, a green apple, an orange. Now it can only have strings, so that can be either in single quotes, it can be in backticks, and it can also be in double quotes. Plus it can be in a format that returns a string. So if we apply a method on a string like to uppercase, although this wouldn't make much sense, but still it's going to return a string, as you can see here. So that can also be added to the array, and it can also contain a function that returns a string, but then this needs to be a self-calling function, so I'll wrap this inside a parenthesis and then call it like this, and this needs to be a string. Alright, so these are a few ways in which you can add strings to an array of strings, but then this won't really accept anything other than strings. So if I supply it strings, but then apart from that, if I supply it a number or a boolean, then it's going to complain, so that's not allowed. It can still have values like the base type, that would be null and undefined, but then apart from that, it can only have strings, either in these cases or in ways that return a string type like this. There is another way of declaring an array. So let's say this time I create a food array. This is going to be an array of type string. So this is another way of declaring that. Now food can also be given all these things: a pizza, burger, and you get the idea, right? So this is another way of declaring that. Now you can also declare an array of multiple types. So this can either have a string or a number, let's say. or it can also have a boolean. Let's call it generic array. And then the generic array can have strings, it can have numbers, also in other formats like a binary. It can have boolean as well, so false and true, and it can also have a null and undefined as well. So these are the two ways of declaring arrays and the values that can be passed to this array. Next up we have tuple. So the syntax of tuple is a little bit similar to that of arrays, but it has some caveats to it. Let's say that we have a tuple and let's call it coordinates, and it's a tuple of number, number, number. Coordinates can be assigned a number 12, 13, 14. But as you saw while I was typing in these two numbers, it was giving me a red squiggly line because it accepts only these three arguments as numbers. So that only is going to work. If I try to assign it something else like a null, it's going to give me an error. An undefined, it's going to give me an error because it accepts only three values and it's going to be numbers only. If I was creating some other generic tuple like this and it accepted a number, a string, and a boolean, at this point it's going to give me an error under these because this was supposed to be a string but was a number instead, and this was supposed to be a boolean but was a number instead. So let's say false here. And this is how tuples work. Now we generally don't use tuples that much in Angular, but just for the sake of telling you guys about it, I've added it here. Next up we have objects, and objects are just similar to the JavaScript objects that we are aware of. So let's say there's a user object. The best way of creating an object is like this in JavaScript, and you can pass it things like properties and methods. Let's say the user had a first name property of Sid and a last name property of Ajmera, and then the user also had a username of Sid Ajmera and method as well in there. So get username, and this would be a function that returns a string, and then I could use this dot username. So here is how you can create objects just like the plain old methods of creating objects, and this is by the way the best way of creating objects in JavaScript, and other ways as well like newing up an object instance. And then the best way and the most recommended way of creating objects is like this. Next up we have enums. So there's a very special requirement for enums, and that if you have some values and these values are very strict in nature, like say for example days of the week, so you can create enums out of them and then use them. Let's say I create an enum days of the week. So you create enums just like you would create classes that we are going to have a look at in later parts of this section, but it can have then some keywords in there like let's say Monday, Tuesday, Wednesday, and so on and so forth. Then if you were to create a variable, let's say day today, and this was of type days of the week, then you can assign it a value of days of the week dot Monday. And as you can see, we are also getting IntelliSense over here. So if I press Control plus space, I get IntelliSense. And you can also see that here we have them as zero based. So Monday is going to have a value of 0, Tuesday is going to have a value of 1, and Wednesday is going to have a value of 2. This is how you can get IntelliSense as well. Now, if you don't want to get these as zero based and if you want to give specific values to them, then you can assign them values as well. So this can have a value of Monday. This can have a value of Tuesday and Wednesday. And then if you hover over this, then it tells you that Monday had a value of Monday in string, and so on with other days as well, like Tuesday and Wednesday. Cool. This is how enums work, and this is one of the use cases wherein you can actually use enums. Next up, we have special type, that's any. So if you don't really want to specify the type of a variable as yet, you can use any as the type instead. So let's say that you have some JavaScript and you want to slowly and incrementally introduce TypeScript in there. Like, say for example, you have an authorized user property, and then this property has some fields like these, and you want to slowly introduce TypeScript in there, but you are not really concerned about the actual type of this particular property, you can specify a type of any in here like this. Now, one of the issues with doing that will be that you won't really get much of IntelliSense in some cases. Like if I do authorized user dot and then press Control plus space, then I'm not really going to get IntelliSense the way I would get if this was specified some type, like first name is of type string, last name is of type string, and username is of type string, something like this. So in this case, you are going to get IntelliSense properly like this, but if it was supplied a type of any, you won't really get any IntelliSense. So this is one of the drawbacks of using any. But initially, if you have some JavaScript in place and you want to slowly introduce TypeScript into it, then one of the ways of doing that would be to use any as the type. Alright, so this was it regarding this video. Just to recap, we learned about these reference and special types like void, array, tuples, objects, enums, and any. And that brings us to the end. In the next video, we are going to talk about operators, and the first one that we'll be having a look at is the spread operator. So I'll see you guys in the next video. It's time for us to understand the spread and the backticks operators, and let's first start with the spread operator. So the spread operator spreads elements of an array or an object, and it can be used for merging multiple arrays and objects into a flat array or object, and it's denoted by triple dots. So let's see that in action, and to do that we'll do the needful of adding the file for operators to the script, and let's also create a operators.ts file, and in the index.html file let's comment all of these and add a script for operators.js. Let's now run npm start, and this will convert the operators.ts file into operators.js as it did here. Alright, now let's go to operators.ts and start with the array syntax. So let's say that I have a variable, let's call this fruits, and it's an array of type string, and it has a few fruits in there like an apple, a green apple, some grapes, and let's create another array and call it food. This is also going to be an array of type string, and let's say that this has a pizza, burger, and it has some fries. Now let's say that I wanted to create an array with the value of the fruits and food in a single array. So this is going to be a edibles array, let's say, which is also going to be of type string. So I can use the spread operator in this case. So we use the spread operator with triple dot and the name of the array. So fruits and triple dots food. Now edibles can be logged on to the console. Let's save and go back to the browser to see what this prints. So as you can see, it has printed all the elements of the first as well as the second array. It has consolidated them into one array and it has printed all of them together. Let's now see how we can use it in an object. So let's say that I have a user object. This user object has fields like first name, last name, and username. And then I have another object, let's say user details. And in here I have an address property and an email property. And now what I wanted is for the user details object to have these three properties as well in here. So I can use the spread operator in this case, and spread out the user object. Now if I log the user to the console and save it and go back to the app, we see the first name, last name and username fields as well, along with the address and email fields that this already had, right? So this is how you can use the spread operator with an array and an object. There is another way of using it with functions. Let's say that I had a function called add, and this function accepted three arguments, say x, y, and z, and then this returned a number, x plus y plus z. This returned a number, and these were numbers as well. So now if let's say I have an array of numbers, that's 1, 2, and 3. And if I wanted to call the add function and log whatever it returns to the console, so I'll call the add method. Now if I didn't really have the spread operator, I would have to do something like numbers of 0, comma numbers of 1, comma numbers of 2. If there wasn't a spread operator, then I'd have to call the add method with the three numbers in this array like this. But now since I have the spread operator, I can simply call it like this. Now it's going to give us an error because the add method accepts three arguments. In this case, we are just passing it one, although it's going to spread them and then generate three numbers for us, but then it's still not acceptable for the add method. So we can make these arguments optional by placing a question mark before their name, and then this is how it makes the code work. So if I save this now and go back to the application, I see that the sum is now printed as 6. Here you can also use the spread operator in this case. Now let's quickly talk about the backticks. Backticks was introduced as a part of ES6 and it basically has to do something with strings. So let's say that I had the user details object and I wanted to print something like the user with name Siddharth has an address of 123 any street and an email of the email that I've specified in that object. I would have to write something like the user dot first name plus and then append the second string would be second string, which would be has an address of user details dot address and an email of user details dot email. Now let's clearly see what's happening here. So we had to place an extra space here. We had to place an extra space here. And we had to make sure that all the plus signs are properly added so that we don't really miss any signs, thereby causing in any error. And this makes the code very messy, I'd say. And I hope you agree with that. So there's a better way of doing the exact same thing but with backticks. Let's first quickly see what this prints to the console. So if I go back to the app and reload the application, it says that the user with name Siddharth has an address of 123 Annie Street and an email of this. Cool. Now I can do something similar with backticks, and to do that I'll just log the exact same string to the console, but this time I'm going to do that with backticks. So I use the backticks sign and then I type something like the user with name, and then I wanted to get the value of user dot first name or user details dot first name, since first name is now also a property of the user details object. I'll use dollar sign along with curly braces, and then inside I'm going to use the user dot first name property. And since I'm using Visual Studio Code, I also get these properties colored in a different color. The user with name this space has an address of, again, a dollar sign with curly braces, and user details dot address, again space, and an email of dollar sign user details dot email. So this is the exact same syntax that we have above, but it's a better version of it because we don't have to type in the extra plus signs, and there's not going to be any trouble if we forget to add them like this, because it's not really needed with the backtick sign. You can also make this multi-line, and As you can clearly see, the backticks syntax is way cleaner as opposed to the one with appending all the property values like this. So if I save this now and go back to the app, let's just reload this. And since I used multi-lines, it's going to print like this, but then that was just for making it readable to you guys. I can revert that and it's going to print in the exact same way as it did for the previous case. So we get the same output here. So whenever you can, you should use the backtick sign. Now backtick sign has an issue that it basically stringifies things. So let's say that if I log got the edibles as, now if I save this and go back, it's going to print all these edibles as comma separated string and not as an array that we can see here. And it's going to do the exact same thing with objects. If I do something like user details here, then it's going to print object instead of printing the actual value of that user like this. So this is the only downside, that it stringifies an array or an object that's passed to it. So if you want to get it printed like an object or an array, you'll just have to use the same regular syntax that you're used to. So a comma and that object after that. So if I save this now and go back to the app, it's going to get printed as an array here and as an object here. Alright, so to recap, in this video we have seen the spread operator, and these are a few properties of the spread operator. We also saw the backticks operator and how it can be used to wrap strings around it and use variables like this, and how it stringifies objects and arrays and what we can actually do to prevent that. Next up, we are going to talk about the destructure operator. So I'll see you guys in the next video. Alright, so next up we have the destructure operator, and destructure operator is used to break up the structure of objects and arrays, and it's essentially thinking about it as plucking elements from an object or an array. In case of objects, we'll be using curly braces to destructure it, and for arrays we will be using a square bracket syntax. And this can generally be seen in import statements, which we'll be having a look at later in this section. But let's quickly go ahead and have a look at the destructure operators now. So I already have this file from the previous video where we talked about the spread and the backticks operators. Let's also now talk about the destructure operator. So in order to destructure something from an object, we'll use something like this. So we already have a user object, and this user object has a first name, last name, and username properties. So if I just wanted to get the first name, I'll destructure the first name like this. And now if I log the first name to the console and save this and go back to the app, it's going to show me the first name being printed here. That's not all. I can also get the last name, and let's print that as well to the console. We'll also see the last name. Now we can also alias the destructured properties, like let's say for example the first name I wanted to call it as F name, and the last name I wanted to call as L name. I can now use F name instead of first name and L name instead of last name, and this still prints the exact same things, the first name and the last name. Now we can do something similar with arrays. Let's destructure some fruits. So if I wanted to, let's say, destructure an apple, I'll get apple, and let's say green apple, and then grapes. So now I can log these to the console. Let's save this and reload the app, and I can see apple, green apple, and grapes being logged to the console. This is us using destructure to destructure an array. Now there is another thing that we can use, and that's called the rest parameters. The rest operator allows us to represent indefinite number of arguments as an array if we call a function, let's say, and it can also be used to represent the rest of an object or an array in general. In case of functions, if we use the rest operator, then it's going to only be the last parameter of that function. and this last parameter must be prefixed with triple dots, and the remaining arguments of that function can then be placed within a standard JavaScript array. Now this is just for the sake of function calls, but then apart from that you can also use it with objects as well as arrays. So let's see that in action quickly. So in the first video we created the edibles array. We can use the rest of the edibles if we want and just pluck apple instead. If we do that, it's going to look something like just apple and rest edibles, and I'll use the rest operator here. Now if I log these two to the console, just apple and rest edibles, and save this and go back to the app and reload it, then I'm going to see just apple that printed this apple, and the rest of the edibles were printed here because of this line here. So we can see that the rest of the edibles from the edibles array were assigned to the rest edibles as an array. We can do something similar with objects. So let's say that we have the user details object, right? I can just get the first name property, and for the rest I can use the rest operator, and I can log the same thing to console. So first name and rest user details. Now these will be printed as the last two things to the console. So if I go back to the app and reload, I can see that the second last thing that got printed was the first name, and the rest of the properties were added as a separate object. Now we can do something similar in case of method calls. So let's say that I had a function get edibles, and in here this is going to get an apple and rest edibles, and then we can simply log apple and rest edibles here. So if I call get edibles and pass it the spreaded edibles, let's make these optional. So what I'm doing here is I'm spreading out the contents of the edibles array, and this is going to be supplied to this as well as the rest of them would be supplied to this. So the item that's present at the first or the 0th index of the edibles array is going to be assigned to apple, and the rest of the array is going to be assigned to rest edibles here. And I can then log it to the console as we can see here. And let's try this by going back to the app and then reloading it. So as you can see here, apple was printed as this and the rest of them were printed here. So this is how you can use the rest operator. And that brings us to the end of this video. In the next video, we are going to talk about TypeScript classes. So I'll see you guys in there. Alright, so it's time for us to now have a look at classes. Now classes in TypeScript are same as those in Java or C#. So if you're coming from a Java or C# background, then you probably are familiar with classes. They are basically blueprints for creating objects, and they can encapsulate data and logic. So it contains properties, getters and setters, methods that you can call, and a constructor function that gets called when this class is instantiated. They can also have properties and methods using the member access modifiers like public, private, and protected, and we are going to have a look at this in this video. They also support inheritance with the help of super keyword. So you can have access to protected or public members of the base class using the super keyword, and they can implement interfaces, and we can use classes to enforce types. So let's have a look at all of this in action. I'm going to switch to VS Code now, and I've already created a classes.ts file. I've added the script for the generated JavaScript file in the index.html, and I've updated my package.json so that my TypeScript compiler compiles the classes.ts file and watches for changes in the watch mode. And the process is already running. So let's go ahead and have a look at classes now. Now in order to create a class, you'll use the class keyword. Let's say that I create a person class. This person class can have properties, methods, getters, and setters. Let's start with properties. So let's say it has a property of first name. which is of type string, last name, which is of type string, and age, which is of type number. This can have a constructor function that is used to initialize the person class with some default values for these properties. So in order to get all these three properties, I'll specify the properties as arguments here. So this will have these parameters for the first name, last name, and age. And this can also have a method which returns a string, and then this returns a string for this dot first name space this dot last name. Now in order to create an instance of the person class, I'll use the new keyword. So let's say that there was a person variable which was of type person, and now the person variable can have an instance of the person class assigned to it, or an instance of a class that inherits from the person class. Now inheritance is something that we are going to talk about later, but let's first initialize the person class with the new keyword. And as soon as I do that, I get a red squiggly line. And the reason for this is that newing up an instance of a person class is going to eventually call the constructor method. And the constructor method accepts three variables as arguments, but we have not supplied any at this point, and that's why the TypeScript compiler is complaining about it. So let me specify those three arguments, and let's say the age is 25. I save this now, and then let me log whatever the get full name method returns to the console. So person dot get full name, and as of now all these properties and methods are public in nature, and that's why when I did person dot, I got all of those properties and methods as suggestions in the IntelliSense. So let me call the get full name, and let's go back to the app, reload it, and I was expecting to see John Doe in the log, but I'm seeing undefined and undefined. And the reason for this is these arguments are not really initializing these properties as of now. So in order to do that, I'll have to use this dot first name equals first name, and so on and so forth for the other two properties. Now if I save this and go back to the app, I'm going to see John Doe getting printed onto the screen, and that was expected. Now this is a bit more verbose in nature, and there is another way of doing this with a shorter syntax. I can specify the member access modifiers right here on the constructor, like let's say private. And what this is going to do is it's going to create properties on the class with these names. And that's why the TypeScript compiler is also complaining, because these properties are already in there. Like if I hover over this, it says that there's a duplicate identifier for first name, because first name was already present here, and doing this would also create a first name property, and that's why there would be duplicate identifiers. So we don't really need these anymore. Also, since I'll be newing up the instance of the person class and passing these values as arguments, which would be received by these parameters, so I don't also need to assign them explicitly here. So I can get rid of this syntax as well. So this is a more shorter way of defining properties and assigning them via the constructor. So if I save this now and go back to the app, it should still show John Doe getting printed onto the screen. Perfect. Now let's say that I also wanted to create an employee class, and this employee class needed to have a few additional properties apart from the first name, last name, and age. So I could clearly copy this code from here and paste it over here, and then add the other properties like middle name, which is of type string, and an ID, which is of type number. And this is not that big a deal because the person class as well as the employee class didn't really have that many properties and methods in place. But let's say for the argument's sake that these two classes had 100 properties and 200 methods on them. So duplicating all those properties and methods would not really make much sense. So if the person class already had all those properties and the employee class needed to just add a few more properties, then duplicating all that code would not really make much sense in this case. So there's a way of inheriting all these properties and methods from the person class to the employee class, and that's how inheritance work in TypeScript. So in order to inherit the person class in the employee class, we can use the extends keyword, and then supply the name of the class that we want to inherit from, which is person in this case. But at this moment, the TypeScript compiler is going to complain because doing this will require us to call the constructor method of the person class inside the constructor method of the derived class, which is employee here. In order to call the constructor method, we'll have to use the super keyword and call it like this. And doing that would get rid of all these red squiggly lines under this section of the code. But since super is going to call the constructor method of the person class and the constructor method required 3 arguments and I'm not passing it any here at this point, it's going to complain, and that's why I'll have to pass it the first name, last name and age. TypeScript compiler is still complaining about it because I duplicated the first name, last name and age properties in the constructor of the employee class, and that's why it's complaining. So in order to get rid of that error, I will get rid of the private member access modifier here, which would not then create properties for first name, last name and age in the employee class, and it would extend them from the person class. Now I can instantiate the employee class by newing it up. So let's say that I create a manager variable and specify the type of it as person. And I'll show you why I'm doing that in the first place. And then I can call the constructor method of employee by newing it up like this. And constructor of employee accepts 5 arguments, but I'm not passing it any. That's why the TypeScript compiler is complaining about it. So let me specify those properties as arguments. So at this point, it's all going to work just fine. Now I've specified person here as the type of manager, but I'm assigning it an instance of the employee class. Why I'm doing that is because since manager is of type person and person is the base class of employee class, I can assign instances of the derived class to a variable of type parent class, and that's why the TypeScript compiler is not complaining about it in the first place. Let's say that I log the full name to the console and I see Jane Doe in here. Now we can also override a property or a method from the base class in the derived class. So let's say that I wanted to override the get full name to also include a middle name in between. So I can do that using get full name and defining it here as well. This also is going to return a string. Let me just return something at this point. So if I try to get the first name here, this dot first name, I'm not going to get that because this does not have first name accessible. I can probably try using the super keyword, but then the super keyword also give me access to just the get full name method on the base class. So I'll probably have to just use the get full name method in order to have access to the first name and the last name, and then I'll have to write some logic in order to insert the middle name in between. So let's say that I get the name segments, which is a string array, and I do that using super.getFullName, and then I split the getFullName by a space like this. Now getFullName returns a string, and the string has a split method on it that returns a string array, and that's what I'm doing here. Now the name segments is an array, so I can call a splice method on it, which accepts 3 arguments. The first argument would be the index at which I want to do the splicing. That would be 1 in this case because I want to insert the middle name in between. So at the 1th index, so I'll use 1 here. The second argument is the delete count, and I don't really want to delete anything as such, so I'll use 0 here. And the third argument would be the item that I want to actually insert in this array, and that would be the middle name. And splice is going to affect the original array, which is name string. So now the name string will have 3 items. 0th index will have the first name, 1th index will have the second name, and 2nd index will have the last name. So I can create a variable called full name here, and I can join the name segments array with the join method, and join it with a space in between. So I'll get the full name as first name space middle name space last name. Let's save this and go back to the app and let's reload this. And this time I see Jane Patrick Doe being printed onto the screen. Now you might not want to write all this logic sometimes in the first place, and there is a better way of doing this. So apart from public and private, there is another member access modifier, and that's protected. And what protected does is it gives us access to those properties in the base class as well as in the derived class, which we are not really having at this point with the private member access modifier. So I can change these to protected, and this time instead of writing this whole syntax and logic, I can simply return this dot first name, this dot middle name, and this dot last name. So if I save this now and go back to the app, I can still see Jane Patrick Doe being printed onto the screen. Now we can also have getters and setters in a class. So let's quickly see those in action too. So let's say that there is an ID here and I wanted to get this ID as employee ID. So I can use the get keyword and then employee ID, which is the name of the get property. This is going to return to me something of type number. Now since it's a get property, it always have to return something to me. So I'll return this dot ID, and then there is also a set property that you can define on it, and this will receive an employee ID as a number, which is then going to be set on the ID property on this employee class. So if I save this now, I can have access to that using the manager variable. So manager dot, but right now it's showing me just the get full name and not those getter methods and setter methods that we used here, even though they are public in nature. And the reason for this is manager is of type person right now, and person don't really have the employee ID as setters and getters on it, as you can see here. And that's why the TypeScript compiler is going to complain about it and not showing us those setters and getters as IntelliSense as well. So I can change this to employee instead, and then manager dot. Now it will show me the employee ID. So as soon as I do that, it's going to call the getter and it's going to return to me the ID property that's present on the employee class. So I can log this as well to the console, and doing this is going to return to me the ID of that employee, that is 1. And then I can also set that. So manager.employee ID is going to be, let's say, 20, and then I can log the changed employee ID after this. So if I save this now and go back to the app, initially it will show me 1, and then when I set it, after that it's going to call the setter method, and then it's going to update it to 20. And that brings us to the end of this video. We learned quite a lot about classes in this video, how classes are blueprints for creating objects, how they can encapsulate data and logic in the form of properties, getters, setters, and method, and the constructor function, how they can have different member access modifiers like public, private, and protected, and how we can inherit a class in a derived class and call methods on it using the super keyword, as well as have access to properties on it. Now classes can implement interfaces, which is something that we'll have a look at in the next video. So I'll see you guys in the next one. Alright, so let's now see what interfaces are and what exactly is their significance. So they are a way of defining contracts, and they can be used in TypeScript for implementing structural subtyping, specifically in objects. Now an interface can extend other interface to add on to the existing contract that the previous interface had, and with the help of interfaces you can set properties as optional or read-only type. And they can be specifically used for enforcing contracts on classes, and they don't have a runtime implementation, which would mean that if you compile a plain old interface via the TypeScript compiler, it's not going to generate any specific code for that interface. So let's see all of this in action. I already have added the interface.js file to a script tag that will be generated for the interfaces.ts file, and I've added that to the start script here. and the process is also running in the background. So we can start by creating an interface. Let's create a person interface, and you do that by using the interface keyword and then supplying the name of the interface. That would be person in this case. Now let's say that this person has a first name property which is of type string and a last name property which is of type string as well. So in order to use an interface and enforce type and a contract, you'll have to specify the type of an object as this interface if you are using it for objects, and if you are using it for classes, you'll have to implement this interface. So let's quickly see how we can use this for objects first. So let's say that I create a user object which is of type person. So as of now, since this is an empty object, the TypeScript compiler is complaining that it has missing properties like first name and last name. So I'll supply these properties to it. Now as soon as I type in, you'll notice that Visual Studio Code gives me IntelliSense. So let's say that this is a string, and it will also need the last name because that was added as a part of the person interface. So last name, which is again a string, and this works just fine now. Now it's going to give me an error saying that it cannot redeclare a block scoped variable user, and that's because the TypeScript compiler compiled this TypeScript code into JavaScript code, and the user variable here as well is going to be present on the window object, and so would be the case with the interfaces.ts files user, and that's why it's complaining. So there's nothing to be worried about. We can ignore that as of now. But as you can see, for this interface code, the TypeScript compiler didn't really compile anything as such. It compiled only the code for objects, as you can see here. And that goes on to prove that the interface does not have any runtime implementation. Now, let's say that I also have another interface called human. And this human interface has an age property which is of type number, and it has a walk property that's a method which returns void. Now interfaces can extend other interfaces as well. So let's extend the human interface onto the person interface. Now as soon as I do that, it's going to complain here in this case because the user at this point does not have the age property and a walk property. So I'll have to add that to it, and then walk is going to be a method. Let's use an anonymous method here that simply returns. And if I save this, everything works as expected, and this is just the block scoped variable that we have already. Alright. Now with the help of interfaces, you can also specify some properties as optional and read only. So let's say for example, we want to make the last name as optional. So we can do that. And if we don't supply a last name here, then it's just going to be fine. There won't be any issues. And in order to make a specific property read only, we'll have to use the read only keyword in front of the property that we want to make read only. Now, if I create a user property and then I try to assign something to age, let's say 20, it's going to give me an error because age is now a read only property, so it cannot be assigned again. Now so far we have seen how we can use an interface to enforce a type on a variable. We can do something similar for classes. So let's say for example we have a class. Let's call this employee class. And if we want to implement an interface on a class, we'll have to use the implements keyword and then supply the name of the interface that we want to implement. So let's say that I want to implement the person interface. So in this case, we'll have to add properties like first name and give it a value. Last name is optional, so let's avoid it as of now. It will also ask me for a age property that I can give as 10 as of now. And then it will ask me to implement a walk method, and this walk method returns void, something like that. And that brings us to the end of this video. Just to recap, we saw how we can use interfaces for defining contracts, for enforcing these contracts on classes, and for implementing structural subtyping of objects. We also saw how we can extend one interface on the top of the other, and how we can set properties as optional and read-only type. And we also saw how an interface does not have a runtime representation. Next up, we are going to talk about arrow functions. So I'll see you guys in the next video. It's time for us to have a look at arrow functions now. So arrow functions are an alternative way of declaring functions, and they're also known as fat arrow functions or lambda functions. You can define fat arrow functions like this, wherein you'll have parentheses, and these parentheses can have parameters. Then you place a fat arrow, that is an equal to sign and a greater than sign combined, and then the body of your function. Some of the key features of fat arrow functions or lambda functions is that they lexically capture the meaning of this as well as of arguments, and they are non-constructible, so they cannot be invoked using the new keyword. Now they are especially useful in TypeScript and JavaScript when it comes to accessing members and variables via callbacks and promises. So let's quickly see arrow functions in action. I've already created an arrows.ts file. I've updated the package.json start script to compile arrows.ts file, and I've added the script for the generated arrows.js file inside my index.html. The script is already running, so let's start with the code now. Generally, if you want to create a function, you'll use the function keyword and then type the name of the function. Let's say greet user, assuming that this receives a name which is of type string, and we can log the name of this user to the console along with the greeting, something like that. Another way of doing the exact same thing is by creating anonymous functions. So you'll create an anonymous function and call it greet user by name. Then you assign it a function that can also accept a name as an argument, and then this can log the exact same thing. Now in order to call these functions, you just call them by their name. So greet user, and then you pass it something as a name, let's say John, and you do the same for the greet user by name method. You call it with an argument. Let's call this via Jane, and let's save this and go back to the application and reload. So it says hello there John and hello there Jane, which makes total sense. So far so good. Now you can rewrite this get user by name function with the arrow function syntax. So I'm just going to copy the exact same function, and let me just rename this to arrow. The name might not make sense at this point, but just bear with me. I get rid of the function keyword and then place an equal to sign and a greater than sign in front of it. And then since this is just one line, I can simply get rid of these curly braces as well. And in just one line, I can write the exact same function which I used 3 lines for previously. So let's save this now, and let me just call this method again, this time with a new name, and save. And if I reload the application, it gives us the exact same behavior as the previous one. And arrow functions come quite handy when it comes to using methods on an array. So let's say that we have an array of edibles, and in there each object is going to have 2 properties. Let's say edible, which is going to be a string, and is vegan, which can be a boolean, let's say false. So let me just copy this object a few times and replace the content. And now from this array I wanted to filter out the objects that are vegan, so the objects for which the is vegan property is true. With anonymous function syntax, I'd have to write some logic like edibles dot filter, and this would get a function as an argument. This function will have each item from the edibles array as an argument, and then this would have to return item dot is vegan, and then I could simply log whatever this returns to the console. And let's save this and run it. So it returns 3 objects. Now this looks a bit longer. You can rewrite the exact same syntax using arrow functions, and to do that, let me just copy this, and edibles.filter, it will get an item as an argument, and since this function inside has just one line, I can get rid of the return keyword and simply return item.isVegan like this. And let me save this, and this now translate to just one line, and let me just go back to the app and check what it prints. And as you can see, it prints the exact same results as this one. So one of the main advantages of using fat arrow functions is that it shortens the lines of code that we have to write. So that comes in handy. The other issue that arrow functions solve is rescoping of this keyword. Let's quickly see that in action as well. So let's say that I have a user object. This user object is going to have some property like first name, last name, and then this has a lazy greet method that greets the user after 1 second. So I'll use a set timeout method that greets the user after 1 second. Now I need the first name, so I'll use the this keyword, which would supposedly point to this object, and dot first name like that. Let's call the lazy greet method now, and let's save this. And let me go back to the app, and it says hey there undefined instead of hey there John. So let me just click on this link right here. It takes us to the generated JavaScript file, and let me just reload the function. Now if I hover over this dot first name is undefined, and if I hover over this specifically, it tells me that this points here to the window object. So the scope of this keyword has changed somewhere. Now in order to fix that, we can do something like create a const here and call it that, which would then point to this, and then we can use that dot first name, save this, go back to the app and reload this, and let's see what gets printed. Now we can see that John gets printed properly along with the greeting. So this is one of the ways with which we solved the issues with the rescoping of the this keyword. But then this is something that arrow functions can solve out of the box. So if I didn't want to do this, I'd simply use the arrow function like this, and this time it's not going to be that dot first name, it's just going to be this dot first name. If I save this and go back to the app and reload it, this time I'll see the correct message that I was expecting. And that brings us to the end of this video. So as we have seen, we can use the lambda functions or fat arrow functions in TypeScript to access member variables through callbacks and promises, and how it can fix the issues with rescoping of this in case of anonymous functions. Next up, we are going to talk about modules. So I'll see you guys in the next video. Alright, so let's now talk about modules. Now JavaScript wasn't really built with modularity in mind, so many developers started using and introducing some of their own constructs in order to make the code more modular. And some of the examples of these constructs are iffy, that's immediately invoked function expression. Then there was CommonJS, that is partially implemented by Node.js, but in case of Node.js, all the files are generally local in nature, so it works synchronously. But in case of browsers, we need asynchronicity because most of the files are generally downloaded via the network. So in that case, for browsers, asynchronous module definition or AMD was also later introduced. Now all these constructs had some shortcomings, and talking about the history of modularity in JavaScript is basically a course in itself. So I'm not really going to go much deeper into that. That's why I've created a YouTube playlist and I've linked that here so you can watch it in order to better understand the rationale behind modularity in JavaScript and why ES6 modules were introduced. Now, ES6 modules were introduced to overcome all these issues that we had with these constructs. One of the major reason is to keep the global scope clean and to provide a better way to share code and work with dependencies in JavaScript. So one of the major characteristic of modules is import and export. So you basically import some module in a specific module, and then you can export some functionality out of a particular module that can later be imported by some other module. And generally in JavaScript, one file corresponds to one module. Now the script tag with the help of which you actually include this JavaScript into your HTML needs to be included with an attribute type, the value of which should be module. And that's how the browser is going to actually consider this JavaScript file as a module and then look at it as a module, and then it's going to basically determine all the dependency graph and things of that sort. So this is how you can basically export some things from a module. So let's say that you have a function called named export. You can name it and then use the export keyword in order to export it. Then you can also export some constant or some variable declared with let, and that's what we have done here. Now, apart from that, you can export multiple things at once. So let's say that you have a function called function A. There is some class in a module, and then there is also some interface in a module. So if you want to export function A, some class and some interfaces, all of them at once, then you can simply write the export keyword, and then inside these curly braces you can specify the names of all the things that you want to export from this particular file, which eventually is going to be considered as a module. Apart from that, there's also a default export. So default export can just be one in a specific module. You cannot have multiple default exports, and in order to default export something, you write export space default. So these are the two keywords that you actually use in order to default export something from a particular file, and that's what this last code snippet is all about. Next, we are going to talk about how we can actually import these specific exported members from a module into some other file or module, and this is how you actually do that. So the first one is a named export. You can actually use this destructuring syntax in order to import something that is named export from some other module. Then if there is something that is exported by default, then you don't really have to use these curly braces in order to import it. So this is how you can import a default exported thing. Then some modules can have some things exported by default, and they can also have named exports. An example of this would be the React library. React has the React object as a default export, but then it also has things like component, which is a named export. So in order to import both of those, you can simply separate a default export and a named export with a comma and import it like this. Now, if you have two different modules that you're importing from, and both these modules export something which has the same name, then in order to import it, you'll have to alias it. Otherwise, JavaScript is not really going to understand it, and it's going to throw an error because there is going to be duplicate identifiers for these two exports that were exported from two different modules. So in order to do that, you use the as keyword and then alias a specific exported member like this. So I've aliased the exported default export like this, and then a named export can also be aliased with the as keyword. Finally, we can import everything that was exported by a specific module using the asterisk or the star keyword, and then we can alias it as something. That's exactly what we have done here. And then we can specify the path from the module where we actually want to import it from. Now, hopefully all these things are clear. Alright, now let's also see all that code snippet in action. So I'm going to create a new folder here and call it module. And inside that folder, I'm going to create a few files. Now remember, each file is a module here. So I'll create a main file first, main.ts. Let's also create math.util.ts, employee.service.ts, and let's also create a dashboard component. All right. So as the name suggests, the math util can have some functions related to mathematics. So function add, which will accept two numbers and then return a plus b. Let's also add a few more functions. So subtract, multiply, divide. And let's also quickly add a log function that's going to do nothing apart from logging something to the console. Now let's say that I wanted to use all these functions inside the employee service. So let me just create a function here called generate pay slip, and let's as of now just log something to the console. And let's also create another function. Let's call it calculate salary. Perfect. Now, in order to calculate salary, we might need some functions related to mathematics, like add or subtract or something. So let me just use the add method as of now here. Now, I don't really have the add method included in this file, which is essentially a module. So let me just import it first in order to use it. So /maths.util, and from there I'm going to import the add method, and let's save that now. Now I'm getting an error saying that the maths.util.ts is not a module. Now this error message might be a bit misleading and counterintuitive, but what it essentially is trying to tell us is that add is not something that can be imported from this module. The reason for this is I haven't really exported something from the maths.util.ts file. So by default, everything is going to be private in nature until and unless it's exported. Since I haven't done that, I'll have to export that first. So export function. And if I go back here now, everything works as expected. But then the add method expects two arguments. So let me just pass it 1 and 2 just for the argument's sake. And everything works as expected now. But since we have quite a lot of functions, and in order to export all of them, we'll have to essentially add the export keyword before all of them. We can somehow shorten the syntax by just getting rid of the export keyword from all of them and then simply using just one export keyword. And then I'll just use the names of the functions right here. So all these functions needs to be exported. Now let me just quickly add a comma as well, because that's how it needs to be exported, as a comma separated list of exported members. So now that I've exported all these methods from here, I can simply use them right inside the employee service. So add. Now, as you also see, if I just press Control plus space, I'm going to get all these methods that are exported from the math.util module in the suggestions. So subtract, multiply, divide, etc. Alright, now let's also say that this also had another function called log. And now in the dashboard component, I wanted to use the methods that are exported by the employee service as well as the math service. So let me just import from maths.util as well as from employee.service. So from maths.util, I'm going to import multiply and log. And then from the employee service, I'm going to import some methods, but looks like I'm not getting any suggestions here, which would clearly mean that I haven't really exported anything from the employee service. So I'll have to export from these files, and then I'll be able to import these methods inside this module. So calculate salary, generate payslip, and log. Now, as you can see, there is a name collision because log is something that's exported by the math util module as well as by the employee service module. So in order to make both of them work, I'll have to alias them. So I can simply alias the log which was exported by the math module as math log, and then I can simply use the log that was exported from the employee service as is. Now let's say that this has a class, and the class has a few things like, let's say, employee ID, and then it also had a create dashboard method. Inside this create dashboard method, let's call all these methods. So calculate salary, generate payslip, then log, and before that let's call multiply and log from here. And we can also export something as a default. So export default this, and let's say that this also had a named export. Okay, now inside the main.ts file, I wanted to import from dashboard component, include the log dashboard activities method. This had a dashboard class that I wanted to import, but then it was a default export and not a named export. So in order to import a named export, I simply use the dashboard like this, and then let's create a dashboard property here which is of type dashboard, and then I can new up the dashboard class like this, and then dashboard will have an employee ID as well as it will have a create dashboard method that I can call like this. Now another thing is that since there was something that was exported by default, I cannot simply default export anything else, because there can just be one default export from a file or module, but there can be multiple named exports. So I cannot do this. But another thing would be that this default export was dashboard here, but I don't really have to just import it using dashboard. I can also import it using some other name, like let's say dashboard component. And now this and this needs to change, but then apart from that everything works just as expected. Another thing would be that since this was exporting multiple things and I wanted to import all of them at once, I can, instead of using this, let me just comment it, I can also use the asterisk sign and alias it as math, and then math is going to be the object that will contain all the things that were exported from the math module, and then I can simply use that object in order to call methods on it like this, and everything works as expected now as well. And that brings us to the end of this video. Hopefully this video has given you a pretty good idea of how you can actually export things from a module, like the syntax that we have right on the screen, and how you can import exported members of a module in your module like this. In the next video, we are going to talk about the fetch API that was also introduced as a part of ES6. So I'll see you guys in the next video. It's time for us to now talk about the fetch API. Fetch was recently introduced as a part of ES6, and it provides an interface for fetching resources, and you can think of it as a better version of the XML HTTP request that was previously used before fetch was not available. The best part of fetch is that it's now native to the browsers and it returns a promise. So you get all the good stuff that promises has to offer. So before fetch, you had to do something like this in order to make an API call. So you would first create an instance of the XML HTTP request, then you would provide it configuration related to what type of request you want to open, what is the URL that this XML HTTP request instance has to target. We also had to manually send that request, and then it provided us with 3 APIs that we could use in order to actually track and see whether the request is in progress or whether it has successfully loaded or whether it has resulted in an error. So it was like a very big API and it was quite complex in nature. Now with fetch, you can do the exact same thing using just a very small syntax. So you just fetch. By default it works in the get mode, so it makes an API call, and that's a get HTTP call. You provide it a URL and then it returns a promise. So you call a then method on it, and then you get the response that was returned from this API call as its first argument. Now this response is of type HTTP response object, so you'll probably have to call a JSON method on it in order to actually get the response that was returned from this API. And then finally, since this is inside a then callback, it also returns a promise. So in the second call to the then method, you pass it another callback that eventually returns to you the exact response that was returned from this API. Let's quickly see this in action though. So I already have the ajax.js file implemented, and here's that file. Now in here we will compare both these implementations. So this was the implementation that was from the XML HTTP request object, and this is from the fetch API. So let's first quickly see this one. In case of the XML HTTP request, you create this instance, then you call open on it, pass it the type of request that you want to make, which is get here in this case, and the URL to which you want to make that API call to, and then you have to explicitly call send method on it in order for it to establish that connection request and then send that request. And then it gives you three callback methods. So one is the onload, the other one is on progress, and the third one is error. On progress is something that tells you about the progress of this API call. Now I have also placed some debuggers in these callback methods so that we can actually check what is the value of this XHR request object. And then we have done something similar but in a more short and concise way. So here we are calling the fetch API. We are passing it a URL, which is the API URL that we have to fetch from. And then this thing returns a promise. So we can chain a then method to it and then pass it a callback function, which corresponds to the success callback. The success callback then receives a response on which we can call a JSON method, which then gets us the JSON object of the response. And then we can chain another then method to it, pass it another callback function, and then this callback function is going to receive the actual API response that we were expecting. Right? So since both these methods are there on the global level and we don't really have a module type attached to the script, it's going to basically end up on the window object. So if I open up the browser now, here I'm going to get both those methods. So the names of those methods were get user via, and these are the two methods that we have. And since we have already placed debuggers on it and the developer tools is also open, after we call these methods, the execution of those methods is going to break on those debuggers so that we can actually have a look at what is the value of those XHR and response objects. So let's first see what this XML HTTP request returns. And it's breaking the execution on the on progress method. The XHR in this case and the event have some values. So the event has all these values and we are basically using the loaded and the total and the length computable properties on the event. But then this event also has some other properties that we could probably use. And then that's probably a value of the XHR as well. So let's make this run again. And then it breaks on this part wherein we have the XHR object now. Let's go to the console and see what this XHR property has. And this is basically the XML HTTP request object that we created right here on this second line. So if I open up this object, then it has all these properties on it, like on abort, on error, on load. And we have the response as well as the response text and all these things of sorts. Now the response is of type string. So if we let this to run further, then we are going to see this string response for the message that we printed on this line right here. Let's see the similar implementation using the fetch API. If I call this now and it breaks on this part right here, I can basically have a look at the response now. Response has all that information that the XML HTTP request object had, but in a better way. So it has the body, which is basically a readable stream. Then it has the response headers. So it has things like OK and then status text and the URL and all those things. Apart from that, it also has some methods in the form of APIs that you can actually use. So one of them was the JSON method that we are calling right here. It transforms the response that we get in a JSON format so that we could get that JSON object right here on this line number 34. Let's clear this console first. And if I let this to run further, then here I'm going to get the actual JSON response that was returned from the API that we can have a look at right here in the preview section. So this was the response and this is what we will be getting. And since this is a promise, it gives us all the good features of promise. So it's obviously better as compared to the XML HTTP request, which is sort of old right now. And it also requires us to write a lot of boilerplate, which isn't really required in case of the fetch API. And that's why most of the current implementations like the service worker is using the fetch API instead of the XML HTTP request. Alright, so that was it regarding this video. In the next video, we are going to talk about async and await, and this next video is going to actually complement this video because async and await works with promises or methods that returns promises. So now that we are well aware of the fetch API and what it returns, it would be better for us to now have a look at async and await. So I'll see you guys in the next video. Alright, so now that we have seen how fetch API works and how we can use it, let's now also have a look at the async await syntax. So async await is some sort of a syntactic sugar and it can be used with promises. So how you do it is that whenever there is a function that returns a promise, you can call it with an await keyword, and then this call should be in a function that's declared with the async keyword. Let me show you how that looks like. So here we have the get user via fetch method. It's a method that returns a promise, right? So in the initialize method, we are calling the get user via fetch method with the await keyword, but the initialize function itself is declared with the async keyword, right? So this is how it works. Now, in order to get the value which was wrapped inside a promise in the get user via fetch method, you don't really have to call a then method and then get the response via a callback, something like this. You can basically get it directly on the user constant right here, and then you can log it to the console like this. Now this might give you a feeling that this code is running synchronously, but it's not. It's just a syntactic sugar. It's anyways going to run asynchronously only. So let's quickly see this in action. Now I already have created an async-await.js file and I've already included it in the script tag right here. In the previous video, we created this method that calls the JSON placeholder API and returns a user. So I'm going to paste it right here. This method returns a promise, right? So I'll just copy this and get rid of all the unwanted syntax like this. Now we need this method to return a promise. So I'll just return whatever is returned from the fetch method because that's basically a promise. And let's create an initialize function here. I'll just call it init for simplicity's sake. And I can now await the get user via fetch method and I can assign it to a variable like this. Now since I'm calling a method via the await keyword, I'll have to declare the function that I'm calling this method in as async, and then I can log whatever this returns to the console. And let's also call this save. And now let me go back to the browser and see what this returns. So if I reload, after some time I'm going to see the user being logged to the console, and this is from the async-await.js file. Again, this is just a syntactic sugar. The code is eventually going to run asynchronously. So that's something that I want you guys to keep in mind. Alright, so that was it regarding this video. Now, as I said while starting this section, TypeScript as well as ECMAScript is highly evolving in nature. So many more new syntax and features are going to be added to these languages. So as soon as these new features come up and they are useful, I'm going to add videos about those features in this section. Alright. Now that brings us to the end of this section. In the next section, we are going to talk about decorators, ng module, and the application bootstrap mechanism in Angular. So I'll see you guys in the next section. Alright, so what exactly are decorators in Angular? Angular is completely filled with decorators of many sorts, and there are mainly class and property decorators in Angular. So let's first quickly see what decorators are. Decorators are a stage 2 proposal in JavaScript, but in TypeScript, they're available as an experimental feature. So you can think of them as functions or higher order functions in case if they accept arguments, which is probably something that you'll see quite often in Angular decorators. And a decorator is something that's prefixed with an @ symbol. And specifically in case of Angular, classes and properties are defined by the decorators that sit on them. And you might hear me say this quite a few times throughout this course, but almost everything in Angular is essentially a class. It's just that it's decorated with some sort of a decorator, and then this decorator actually transforms this class into either a module or a component or a service or a pipe or a directive or any such building block there is in Angular. Now there are a few common decorators that we use quite often in Angular, and these are the ng module decorator, the injectable decorator, and so on and so forth. Here's a not so complete list that you can have a look at. And as far as the class component goes and how they are actually involved in the whole development process, you might probably see code that looks something like this, where everything is a class, which would be the app module in this case, and this class is decorated with the @ng module decorator, and then we have also passed some sort of a configuration object to the ng module decorator. In case of components, this is how the app component class looks like. It's decorated with the @component decorator, and for this as well we are passing some sort of a metadata object. Same would be the case with a directive, which is decorated with @directive decorator, and a pipe, which is decorated with the @pipe decorator, and finally, in case of service, which is decorated with @injectable decorator. And then there are also some property decorators that we didn't really have a look at in these slides, but then we are going to have a look at them in the later sections of this course. And decorators are a section in itself, so we'll have an in-depth look at them in one of the later sections in this course. Let's first now talk about the Angular modules and the ng module decorator in the next video. Alright, so let's talk about Angular modules. Now I hope that you remember a few slides from section 1 of this course where we talked about this Angular application as a tree of components. So we broke this application down into 4 specific sets of capabilities or workflows, and this was the auth, product, cart, and checkout. So we broke this application down into 4 modules: the cart module, the auth module, the product module, as well as the checkout module. And then we also discussed how each module could have some other components, directives, pipes, services, etc. So in case of Angular as well, a module can be considered as a cohesive block that is dedicated to a specific application domain, a workflow, or a closely related set of capabilities. And Angular applications are modular, so Angular has its own modularity system that's called ng modules. An Angular application must have at least one ng module, and that's the root module. Conventionally, the root module is also named the app module. And modules are a great way to organize an Angular application and extend it with capabilities from external libraries. And many Angular libraries are modules in themselves. The Forms module, the HTTP client module, and the Router module are a few examples of some of the Angular's own libraries, which are ng modules. Many third-party libraries are available as ng modules as well, such as Angular Material, Ionic, and Angular Fire. Now creating a module is very easy, and it's recommended to use Angular CLI for it. You use the generate command of Angular CLI in order to generate a module. So you run ng space g, that stands for generate, space m, that stands for module, and then you supply the name of a module. Once Angular CLI finishes running this command, it generates a folder with the name that you have specified here, and then it generates a file inside that folder with the same name that you have specified here, with an extension of .module.ts. This is how it generates that file, and based on the version of Angular CLI that you are using, you might also see a message that looks something like this. So let's quickly go to our Visual Studio Code. And this is the same project that we created in section 1 of this course. Let's now quickly generate a module. So again, ng space g for generate, m for module, and let's say that we wanted to generate a module named core. So I'll type in core here and press enter. And as also said previously, by default for a module as well as for a component, Angular CLI is going to generate a folder. So it did generate a folder for us named core, and inside that core folder it generated a core.module.ts file for us. If I open that up, this is the module that was generated. And again, an Angular module is just a plain old TypeScript class. It's decorated with an ng module decorator, as you can see here. Now generating a module in StackBlitz is also quite easy. So if you have a StackBlitz open up in front of you, you can simply right click on the app folder, and inside you just select the Angular generator and module, and then type the name of the module that you want to create. So I specify core, and then it generates a core folder inside which it generates core.module.ts. This again is the exact same file. You have a TypeScript class that's decorated with an ng module decorator. Alright, now an Angular module in its full glory would look something like this. So it's a plain old TypeScript class that is decorated with the ng module decorator that we can see here. And this ng module decorator is passed some sort of a metadata object that looks something like this. It has a few properties like declarations, imports, exports, entry components, providers, and bootstrap. These are a few properties that are used to configure an Angular module. So let's quickly have a look at these properties one by one. In the next video, we are going to talk about declarations property. So I'll see you guys in the next video. Okay, so what's declarations array? Now you can think of the declarations array as a means of registering an Angular component, a pipe, or a directive onto an Angular module. And by the way, these three things, that is the Angular pipe, a component, or a directive, are also called declarables. So if we have a look at the Angular module again, which is our app module, in the ng module decorator, we are passing a metadata object, and this metadata object is having a declarations property here. This declarations property is an array. So this array can contain only Angular components, Angular directives, and Angular pipes. Declarations accepts a set of declarables that can be registered on an Angular module. The declarables here again being an Angular component, an Angular directive, and an Angular pipe. But they don't accept things like Angular modules, which are TypeScript classes decorated by the ng module decorator. They don't accept Angular services that are TypeScript classes decorated by the injectable decorator. They don't accept non-Angular classes that are plain old TypeScript classes. And they also don't accept declarables that are registered on some other Angular modules. Also, if you try to use a specific component or a declarable in an Angular module without registering it onto it, that is, without adding it to the declarations array, then it would also result in an error. You can read more about the declarations array following this link right here. Let's now quickly see all these aspects of declarations array in VS Code. So I've already opened VS Code, and in the last video we also created a core module, right? So now let's quickly add a few Angular building blocks in order to justify and validate those points that we discussed in the previous slide. So for that I'm going to create an Angular service. So to do that I'll type in ng space g for generate and s for service, and I'm going to generate this service at the root. Let's call it the user service. Now for services, Angular CLI doesn't create a folder, so I'll have to generate in such a way that it generates a folder for us. So I want Angular CLI to generate a user folder inside which I need a user service. So I'll specify ng space g for generate, s for service, and then user/user. So what the Angular CLI is going to do now is it is going to generate a user folder inside which it generated two files, that is the user service file and the test case file for user service. Let's create a component now. So ng-gc, g for generate, c for component, and then let's create a user component. Now since a user folder has already been created, it's going to add the user component files right inside this folder, and it generated four files here. One is an HTML file, that's the component file, the test case file, the actual component TypeScript class file, and then some SCSS file for styling the user component. Let's now create a model class. So for that I'll use CL, that's for class, and then let me create this inside a folder named model and then user. So now the Angular CLI will generate a model folder inside which it will create a user class that it did right here. And now let's also create a component inside the core module. So ng-gc, and now I want this component to be created inside the core module. So core slash, and let's say that we wanted to create a header component. So header, and this will create a folder inside the core folder called header, inside which it is going to create all these 4 files for a component. And it will also update the core module. Since I have wanted to create a header component inside the core module, the header component must be registered on the core module in order for it to work properly. So Angular CLI automatically added the header component to the declarations array in order to register it there. Let's now also quickly create 2 more building blocks, that is a directive and a pipe. So nggd, that is for a directive, and let's call it transform. So it generated these 2 files here. Now, as you can see, since we really didn't specify a folder name here, it created both these files right at the root and not inside a specific folder, just the way it created a folder for the user service that we created initially. Let's also quickly see how we can create a pipe with a folder for it. So if we specify pipes slash safe, then it's going to first create a pipes folder, inside which it's going to create a safe folder, inside which it is going to create a safe pipe file and a unit test file for the safe pipe. It created a pipes folder, inside which it created a safe folder, inside which it created 2 files, one for the Angular pipe and the other one for the unit test for this pipe file. Now let's quickly validate all those things. So I'm going to run ngserve now. Now when those files were created, the app module was updated as well. So Angular CLI took the responsibility of automatically registering the components, the directive, as well as the pipe right onto the declarations array so that we could safely use these things inside our Angular application. Now let's wait for the Angular application to build up. Alright, so our Angular application has now compiled successfully. Let's try to open the application in the browser. So as we can see, the Angular application is running as expected. Now let's try to validate the points that we discussed in the previous slide. As I said, the declarations array in an ng module decorator accepts only components, directives, and pipes, right? So if I try to add an Angular module in here, like let's say if I wanted to add the core module, let me just import it as well. So I've added the core module to the declarations array now. If I save this, it compiled successfully. But then if I go back to the application, I'm getting an error now. So if I go to console, I'll see an error that looks something like this. Unexpected module core module declared by the module app module. Please add a pipe directive or component annotation. So what that would mean is that the core module, which is already an Angular module, cannot be added to the declarations array of the app module. So if I remove the core module from here and save this, everything is going to work as expected now. I can also not add a service to the declarations array. We created a user service, right? So user service. So if I add the user service to the declarations array and save this and go back to the application, I'm going to see an error saying unexpected value user service declared by the module app module. Please add a pipe, directive, or component annotation. So again, that goes to prove the fact that the declarations array can only accept a component, a directive, or a pipe, and not a service. Let's try to add the user model class. So user, let's save this, and I'm going to get a similar error in this case as well. So it will say unexpected value user declared by the app module. Since user is a plain old TypeScript class and not an Angular directive or a pipe or a component, Angular runtime is throwing an error here. Next up, we have the header component declared inside the core module. So if I use the header component here as well, save this and try to use the header component inside the app component and go back to the application, I'm going to see the header component working perfectly. But let's do something else now and try to add the core module inside the imports array. We'll see what this does, by the way. Just bear with me and let's try to add the core module to the imports array and save this and go back to the app. Now I'm going to get an error. It says that the header component is a part of declarations of two modules, core module and app module. Please consider moving the header component to a higher module that imports core and the app module. What the Angular runtime is trying to tell us is that we can declare a component only on one Angular module as long as they are interacting with each other. What that would mean is if I remove the core module from here and save this, since the header component was declared on the app module as well as on the core module, if I'm not letting the core module as well as the app module communicate with each other, it's going to all work as expected. But as soon as two modules registering the same component interact with each other by, let's say, importing one or the other. So let's say if I imported the core module here back again and save this, the Angular runtime is going to get confused as to which specific header component are we talking about here. Are we talking about the header component that was registered on the app module, or are we talking about the header component that was registered on the core module? So that way the Angular runtime is going to get confused and it's going to throw an error in this case. So ideally it's a better way to either declare this header component on a specific module that is later imported by the app module as well as the core module, or just declare the header component on only one Angular module and not both of them. Alright, so let me just get rid of the header component and I can simply import the core module in order to use it and save that. This time as well, I'm going to get an error because the app header, which is the header component, was registered on the core module. So I'll have to do something in order for it to be usable in the app module. And we'll see that when we have a look at the exports array. Okay, now let's say that I wanted to use the user component inside the app component HTML. So I'll just type in app-user and save this. Let me just zoom this in a bit. So I see user works here, right? And I'm able to use it inside the app component that is registered on the app module because the user component as well was registered on the app module. But if I remove the user component from the declarations array of the app module, and then if I try to use the app component here, then I'm going to get an error saying app-user is not a known element. So in order for us to use a specific component in a module, we will have to declare it or register it onto the declarations array of that module in order to use it inside one of the module's components. So as soon as we do that and go back to the application, everything would work as expected now. I think that was quite a lot that we covered in this video. Just to recap, declarations accept only declarables that needs to be registered on an Angular module. So a declarations array is going to only accept Angular components, Angular directives, and Angular pipes. They are not going to accept an Angular module, an Angular service, any regular TypeScript class, or a component, directive, or pipe that has already been registered on some other Angular module. Also, a declarable is not going to work in an Angular module if we haven't really registered it onto the declarations array. And that brings us to the end of the video. In the next video, we are going to talk about the imports array. So I'll see you guys in the next one. So what is this imports array? Imports is a way of extending capabilities that are exported by some other Angular modules into your Angular module. So we have this app module, right? And then we have the ng module decorator decorating it, inside which we have the imports array. This imports array is containing a list of some modules like the browser module, the core module, shared module, as well as the app routing module. Now, all these four modules might export something that we would need to use inside our app module. So in order to get a hold of those exported members from these four modules into our app module so that we could use them, we'll have to add these four modules to the imports array of our app module. So the imports array accepts only Angular modules, and then declarables and Angular modules that are exported by some other Angular modules can then be used inside our Angular module. We are going to get an error if we add any declarable or a normal TypeScript class or an interface to the imports array. But then since the imports array as well as the exports array works hand in hand, let's also see what the exports array means so that in the code we can have a look at both of them in sync. So what exactly is the exports array? Exports array is a means of exposing declarables and imported Angular modules from an Angular module into some other Angular module. So the imports array as well as the exports array work hand in hand. Whatever you export from an Angular module will then be available as a part of some other Angular module that is importing this Angular module. And this will get clear once we see that in code. The exports array accepts a set of declarables that can be components, directives as well as pipes, and it also exports Angular modules. So it will also accept Angular modules that we need to be exported from this Angular module. And it can be said that whatever is exported from an Angular module is available as a part of that module's public API. And since we can also add Angular modules to the exports array, what will happen is that if we have added module A to the exports array of module B, then module B would contain everything that was exported by module A as a part of module B's public API. Let's now quickly see all these points in action. So I already have the Angular application that we were running in the previous video. It's already being served. Let me open another terminal here, and to open that I just clicked on this plus sign here. Let me just change it to command mode, and now I'll just create some declarables that can be registered on the core module, and then we will be exporting them so that we could use them inside our app module when we import the core module inside our app module. So we have already added a header component to the core module. Let's also add some other declarables like a pipe and a directive. So let me now quickly generate a core pipe first, and I'll be generating that inside the core folder itself. So ng generate pipe, and then inside the core folder I'll generate a core pipe. Let me now also generate a directive now, and I'm going to call it the core directive. So ngd, and that generated the core directive. Let's excuse the name of the pipe as well as the directive as of now. We'll be naming them more appropriately when we start to build something that makes more sense. Now inside the core module, we see that both the pipe as well as the directive are being added to the declarations array, and we have already seen what the declarations array is, right? Now the exports array can export these things so that I could use these things once I import the core module inside my app module. So let's say that first, before exporting the header component, I just wanted to use that inside my app module. So I'd go here, and inside the app component of the app module, I would try to use app header like this, and the Angular app is already running. So if I save this and go back to the application, I'm going to see an error saying that the app header is not a known Angular element. And that is because the app header is registered on the core module, but it has not been exported by the core module. So even if I import the core module inside my app module, I won't be able to use that. So if I wanted to use the header component inside the app module, I will have to export it from here as well. So now that I have exported the header component from the core module and I have imported the core module inside my app module, I will be able to use the header component inside my app component. So if I save this now and go back to the application, I should see the header component working as expected. So same would be the case with the core pipe as well as the core directive. So if I wanted to use both of these, I would have to add them to the exports array as well. So core pipe and core directive. So now that I've added both of these to the exports array, and I'm already importing the core module inside my app module right here, I will be able to use both of these as well inside the components of my app module. Another thing that we can quickly see is that I'm going to get an error if I try to add anything else apart from an Angular module to the imports array. So let's try to add the user, which is just a model service. And in this case, I'm going to get an error that user is imported by the app module. Please add an ng module annotation. And we'll get the exact same error if we try to add a user service, which is an injectable. In that case as well, we are going to get the exact same error. And if we try to add any other TypeScript class that is not decorated by an ng module decorator to the imports array, we are going to get an error of that sort. And that should pretty much help you understand the imports array as well as the exports array and what exactly is their significance. Let's also quickly recap what we have seen in this video. So in case of the imports array, it only accepts Angular modules, and declarables as well as Angular modules that are exported by an Angular module can then be used when we add that module to the imports array of our Angular module. And the imports array only accepts Angular modules or classes that are decorated by the ng module decorator. Similarly, the exports array accepts declarables, that is Angular components, Angular directives, and Angular pipes, and they also accept Angular modules, and we can add those as well to the exports array. And whatever is added to the exports array is added as a part of the module's public API. And what that would mean is that if, say, module A is added to the exports array of module B, then module B will have the declarables that are exported by it as well as those that are exported by module A as a part of its public API. And that brings us to the end of this video. In the next video, we are going to talk about the providers array. So I'll see you guys in the next one. Next up, we have the providers array. So providers array can be considered as a means to register a set of injectable objects onto an Angular module. We'll see what injectable objects are in a later section of this course where we'll be talking about dependency injection. But let's quickly see how this works on code. So we have this ng module decorator wherein we are passing in a metadata object onto it, and then this metadata object has a providers array. Now this providers array can accept a set of injectable objects. We'll see what injectable objects are, but adding these injectable objects here make them available on the injector of this Angular module. So we will be able to add these objects as dependencies to the components, directives, or any other Angular building block if we want to, as long as we have added it to the providers array. And making these dependencies available to inject in declarables or services is a responsibility of the Angular's module injector. So we'll be also seeing what module injectors are in that section of this course, but just bear with me as of now and just keep this in mind that there is one providers array that can be used in order to configure all those dependencies. There's also a bootstrap array on the ng module decorator's metadata object. So this is a means of telling Angular that it has to bootstrap these components as soon as it bootstraps that particular module. So we have this ng module decorator with this metadata object, and we have the app component here on the bootstrap array. What this is going to tell Angular is that whenever Angular instantiates the app module, it also has to instantiate the app component along with it. So the bootstrap array accepts a set of components that you want Angular to bootstrap when the Angular module is bootstrapped, and it is generally present only on the root module, which in our case is the app module by convention. So let me show you in code what that actually means. Right now we have the app component, and that is on the bootstrap array of the app module. So as soon as Angular instantiates the app module, it is also going to instantiate the app component, and that's how we are having access to the app component via its selector inside the index.html right here. Now let's say that I wanted to also use the user component right on the index.html. Let me try to do that by typing in the selector of the user component, that is app user. And now since the app is already running, let's quickly switch back to the browser to see what this looks like. So as you can see, I don't really have access to the user component as of now, and it seems that the browser has completely ignored this app-user tag. And the reason for that is whenever the app module bootstraps, right before that, the index.html is also going to get instantiated, wherein it is going to look for a component with this specific selector. And since we have added the app component to the bootstrap array, the app component is going to get instantiated right along with the app module. And that's why when we use the selector tag for app root in the index.html, we are able to see the markup of it on our Angular application in the browser. But that's not really happening with the user component because we haven't really added it to the bootstraps array. So the browser is just going to think of it as one specific HTML tag that it doesn't really have any idea about. And that's why it's not rendering that component. But then as soon as I add the user component as well to the bootstrap array and save it, I will be able to see the markup for the user component onto the browser. Now, the bootstrap array only accepts Angular components, which is TypeScript classes that are decorated by the component decorator. So I cannot really add anything apart from components onto the bootstrap array. And one of the other reasons why I cannot do that is because any component that is added to the bootstrap array is also going to be added to the entry components array. Now we'll shortly talk about what this entry components array is all about. But let me first show you the error that we are going to get when we try to add any other class apart from the component class to the bootstrap array. So let me try to add the transform directive. I'll save this and go back to the browser. And I get an error saying that the transform directive cannot be used as an entry component. Now it's specifically mentioning entry component because as I said, any component or token that is added to the bootstrap array is also going to by default end up being added to the entry components array. So the transform directive doesn't really work in this case. Let me try to add the save pipe. So I save that, go back to the application, and now it gives me a similar error for the save pipe as well. And same would be the case if I try to use the user service or the user token right here in the bootstrap array. If I save this now, it should all work as expected because the bootstrap array now just has components. Now we did see this entry components thing in the error, right? So what exactly are entry components? Entry components are a means to register components that we want Angular to be able to dynamically load into the view. So we have this ng module decorator wherein we have passed a metadata object, and this has an entry components array right here. The entry components array accepts a set of components that we want Angular to compile when the Angular module is defined. And this is how the component gets listed to be dynamically loaded onto the view. So as soon as we add any specific component to the entry components array, that's what tells Angular that these are the components that we might want in the near future to be able to be loaded dynamically onto the view. So in order to do that, Angular creates a component factory for each of these components and then it stores them in a component factory resolver. So by adding components to the entry components array, we are telling Angular that we might want to bootstrap these components in an imperative way. Now in the next section of this course, we will have a look at loading components dynamically onto the view. So please bear with me as of now and just take this particular section of this video as a primer to the entry component section, and then it would make more sense once we have a look at this in code in the next section of this course. And that brings us to the end of this video. In this video, we had a look at the providers array, the bootstrap array, and the entry components array, and what exactly is their significance in case of Angular modules. In the next video, we are going to talk about Angular applications bootstrap mechanism. So I'll see you guys in the next one. Now that we have covered so much in depth about Angular modules, let's finally talk about the Angular application bootstrap mechanism. An Angular application doesn't just run on the browser. It also runs on various other environments like the server when it comes to server-side rendering, and also on web workers. So there are many ways in which we can bootstrap an Angular application depending on how exactly we want to compile it and where exactly do we want to run it. There are basically two ways of compiling an Angular application, the ahead of time compilation as well as the JIT compilation. By default, in the serve mode as well as in the build mode, we use the JIT compilation, but we can provide a flag of AOT in order to compile our applications ahead of time. But for the sake of this video, let's just focus on compiling our application dynamically using the JIT compiler. Now our Angular application has a configuration file. This configuration file is used by Angular to determine the entry point of our Angular application as well as some sort of an entry point for our templates, which would be the index. And overall, our Angular application needs a browser platform wherein it can run the dynamic JIT compilation, and it also needs an execution environment wherein it can run the Angular application. And all of this happens in the main.ts. So let's first talk about the angular.json file. So I have the angular.json file opened in front of me right now, and it has this architect build object wherein we have provided some options, and all of this code is being generated by Angular CLI itself, so we don't really do anything here. But this configuration file allows us to basically configure all these other aspects of the Angular application. Let's first focus on the main as well as the index properties. So the main property is the name of the entry point file, as you can see here. And then we also provide the index file that is the application's HTML index. Let's first quickly have a look at the index.html file. We have an app-root tag specified here. And at this moment, Angular application has no idea of what this app-root tag is. But then it runs the main.ts file, which is our entry point for the TypeScript or the JavaScript code. Here we are calling the platform browser dynamic method, which we have imported from angular/platform browser dynamic package. This method is responsible for creating the browser platform that our dynamic JIT compilation can work with and the execution environment wherein our Angular application can run. So by calling this method, we are creating these two things, and then it also exposes a bootstrap module method. To this bootstrap module method, we are passing in an Angular module. So this would be the root of our Angular application, the root module, which is also by convention called the app module. So we have created an app module right here. And inside that app module, we have a bootstrap array that has app component in it. Now we have already seen that whatever is present inside the bootstrap array gets instantiated as soon as the module gets instantiated. So as soon as the app module gets instantiated, the app component also is going to get instantiated. So Angular is then going to go to the app component TypeScript class, wherein it will see the selector. This is the CSS selector, basically the HTML tag that we have used inside index.html right here. And then there is also a template URL field which points to the template of app component HTML, which is this right here. So Angular now has an idea of what this HTML tag is all about, so it can work with it because it has already run the main.ts file, it has already instantiated the app module, and in the process it has also instantiated the app component. So now it can basically inject the template of app component inside the opening and closing tags of the app root right here. So when we try to run the application, we'll see that the template of app component is wrapped with the app root tag. So if I go back to the browser, I'll see that inside the elements section, I'm seeing the app root tag inside which there is some template, and this is the exact same template that we have on the app component HTML. So as we have seen, the angular.json file is basically used to configure the main entry point of our Angular application as well as the index for our Angular application's markup. And then we need a browser platform to run our dynamic JIT compilation as well as an execution environment, which is then provided by our main.ts file, wherein we run the platform browser dynamic method. And then we bootstrap the app module, which internally bootstraps the app component. And then the Angular application is able to make sense of this app root tag, which we have used inside the index.html file. Hopefully this should give you a pretty good idea of how an Angular application bootstraps. And that brings us to the end of this video as well as this section. In this section, we have learned quite a lot about Angular modules and how an Angular application bootstraps. The next section is all about component decorator and what are Angular components. So we'll talk about Angular components, different ways in which they can communicate with each other. What is the change detection mechanism in Angular? And what are the different lifecycle hooks for an Angular component? So there's a lot to cover. In the next video, we'll start with Angular components. So I'll see you guys in the next one.